Hi everyone, welcome to PrepFusion. So this is the fourth lecture of antenna. In the previous three lectures, we have studied the basics of antenna. Then we studied about Hertzian dipole antenna and its radiation pattern. And then we studied about linear dipole antenna having length greater than lambda by 10 and their radiation pattern. So in those radiation patterns, we studied about radiation pattern as well. We studied about half power beamwidth as well. And we studied about first null beamwidth as well. So all these points are clear. Like when first null beamwidth can be asked, when half power beamwidth can be asked, when radiation pattern can be asked, that also we have seen. So these are the characteristics of an antenna. Like if there is an antenna, you define some characteristics. So radiation pattern, half power beamwidth and full null beamwidth. So that we have already studied. Now we need to start studying about radiation intensity. Then we will study about directive gain. We will study about directivity. We will study about power gain. So all these terms we need to study. So before that, we will understand a very simple concept, that is the concept of solid angle. So we already know what is a planar angle. This angle we have already seen. Like there is a arc. Now this arc could be having two radiuses. So where is the other pen? Yeah. So basically, what is the angle between these two lines? This is the angle, right? D theta. This D theta. This is known as planar angle. So planar angle we already know. We need to study about solid angle. So first let's write down about planar angle. So what is this D theta? D theta is equals to arc by radius. So dl by r, right? So this is also a length meter. This is also a length. This is also meter. So meter by meter. So it is unitless. But what is the unit of planar angle? Radian, right? The unit of planar angle is radian. So planar angle we already know. Now we need to study about solid angle. So planar angle is the angle in 2D. Like there is an arc. Now this arc will make angle theta on origin or angle d theta on origin. This arc is making angle d theta on the origin. Now I am taking a small surface. What I am taking? I am taking a small surface ds. Now this small surface ds, how much angle it will make at the origin? So surface will be 3D, no? Surface will make a 3D angle on the origin, no? Here, this was an arc. It was making d theta angle. That was planar angle. Because that is 2D only. Because this arc can be made on a plane. So that's why we call it planar angle. But what is the thing with solid angle? Now this surface will make how much angle at the origin? So let's start that out. So from this particular point, there could be some line coming. From this particular point, there could be some line coming. From this particular point, there could be some line coming. From the other point as well, there could be some line coming. And although this diagram is not that good, from here as well some line could be coming, and from here as well some line could be coming. So can you imagine it will make a 3D angle? Again, in this manner. So it will make a 3D angle here, right? I am showing it in 2D, but try imagining a sphere. This is a globe. Try imagining a sphere. So now if you take a small surface, if you take a small surface on this one, and then you think that inside at a random point, how much angle it will make? So from that surface, the angle will be 3D, no? So that is known as your, so that is known as your solid angle. So this I am showing as d psi, okay, d psi. That is my solid angle. So planar angle was defined as d theta equals to dl by r. So how this solid angle is defined? So solid angle is defined as ds divided by r square. What is r? This is your r. This is your r. So that was defined as dl by r. This is defined as ds by r square. This is also meter square, and this is also meter square. So meter square will get cancelled. But what is the unit? What is the unit? Unit is stay radian. Okay, stay radian. What is the unit? Stay radian. Here, what was the unit? Radian. Here the unit is stay radian. Are you getting this point? What it is called as stay radian. So unit is STR. A lot of time it would be written STR. Or I'm not sure if this is the spelling. Stay radian. This is the spelling, I guess. I'm not sure about the spelling. You can check spelling on internet. But a lot of time STR would be written. So unit is STR. Now let's write this solid angle more. So what is this ds? Can you tell me? So can you tell me the ds of this particular surface? This surface is coming from a sphere, right? This is a sphere. This surface is coming from a sphere. What is the equation of this surface? Can anyone tell? Those who have studied coordinate system, they will be able to tell it. What is the equation of this surface? R equals to constant. Because here theta is also changing and phi is also changing. What I am saying is that here theta is changing and phi is also changing. So theta and phi both are changing, but R is constant here. So if the equation is R equals to constant, then what would be your ds? What would be your ds? So ds would be R square sin theta d phi. So if you have studied coordinate system, then you would be able to tell. But in the first lecture of antenna, what did I tell you? So whenever I talk about ds, you need to write down this surface area. In case of antenna, whenever I talk about ds, you need to write down this surface area. Did I tell you this thing? Certainly I have told this thing, right? So r square sin theta d phi divided by r square. Divided by r square. So your solid angle is coming out to be sin theta d phi. This theta word is very complex yaar. Who put that word? इससे अच्छा sin A sin B use कर लेते. We could have used sin A sin B. Why sin theta? Okay, theta word is very complex. Yeah, so this is the solid angle. Now let's remove it off. This is your solid angle. So now it will not be asked in your examination, and no question can be framed from this particular angle. But the thing is, somewhere in our analysis, I will be writing this particular thing, sin theta d phi as solid angle. So there you should be, and there you should not have this doubt that, sir, what do you mean by solid angle there? So that's why I took some time to explain you the solid angle. Now let's go to our concept, that is the radiation intensity. So we have already studied about radiation pattern, half power beam width and first null beam width. Now we need to study about radiation intensity. So everything starts from P radiated. Now here there will be a lot of terms and a lot of formula. So I will tell you a certain way that how to remember the things and how to proceed in the examination. So so don't get confused with a lot of formula and don't be stressed that how we will be able to remember the formula. Believe me, I will hardly ask you to remember one or two formula. Okay, and these topics are very, very important for your examination. Let me take a break. I am having again cough, so I will take a break and then I will come back. Yeah, okay, let's restart. So what you can write as P average? What is your P radiated? Let's write it down again. What is your P radiated? So I hope you would be knowing this thing. This I have told a lot of time. My P radiated is P average dot ds. So can I write down P average in this manner? What is P average? So P average is having some magnitude and the direction would be in the direction of radiation. So P average was written, it was having some magnitude. That magnitude will be E theta s whole square divided by 2 neta. So that magnitude I am not caring about as of now. But can I write down it is having some magnitude and direction? So I can write down P average AR cap dot product with ds vector. So what is your ds vector? That I have already told. That is r square sin theta d phi in the direction of r AR cap, right? Because r is equals to constant surface we already take, and we know that ds force pair would be r square sin theta d phi. Although there are other ds as well, but those we will not be taking in care because we need to take that ds vector in the direction of radiation. So in the direction of radiation, ds vector is this. Now AR cap dot AR cap will be 1. So what you are getting? Your P radiated is P average dot r square sin theta d phi. So till this step, all things are clear, right? It is very easy. Now you let me know one thing. P average will be a function of theta and phi. Say yes or no? Although whatever the antenna that we have studied about linear dipole antenna and we have studied about Hertzian dipole antenna. So there this P average was function of theta only. How? Because what is P average? E theta s square divided by 2 neta. And what is your E theta? For E theta was the function of sin theta for Hertzian dipole, and for linear dipole it was a function of f theta, right? For linear dipole it was a function of f theta. So always it is a function of theta, but for some antenna it could be a function of phi as well. In radiation pattern, I told you that whatever the antenna that we are studying, at that time your E theta, or you can say your normalized value of electric field, will be a function of theta. But for some other antenna it could be a function of phi as well. So now this P average dot r square, P average into r square, this term is known as radiation intensity, which can be a function of theta and phi. R square is simply radius, that you don't need to care about. R square is the radius, but what is P average? P average is E naught square by 2 E theta square by 2 neta, and E theta could be a function of theta or phi as well. So this term is known as U theta phi. And what is this term? This term is solid angle. Say yes or no. So this is another formula of P radiated that you are getting. No need to mug up anything. I will tell you that how you would write down it very quickly. So what is this U theta comma phi? That is your radiation intensity. This term is your radiation intensity. So if in the examination radiation intensity is given and they ask you to find the P radiated, will you be able to find out? Yes, because you know the limit of theta and phi, right? Here limit of theta and phi you know, right? Limit of theta and phi you can put. Okay, so P radiated you would be able to find. Very easy. So this is the formula of P radiated you are getting, where U theta comma phi is the radiation intensity. So rather than remembering that U theta comma phi is equals to R square into P average, you remember this process, that where did we start from? We always start from P radiated. So P average into R square sin theta d theta d phi. So R square into P average is your U theta phi. So this is your radiation intensity. So rather than remembering the formula directly, we would better prefer remembering the process, that how we got here. So this is known as radiation intensity. So these things I have written. Radiation intensity is R square into P average, and P radiated is given by this. So you would be able to write it down very quickly. Now there is a hypothetical antenna that is known as isotropic antenna. When we studied Hertzian dipole, we made its radiation pattern, right? So it was like this, and in circular manner it will keep on moving. So radiation pattern was saying that at theta equals to 90 degree you will get the maximum radiation, at theta equals to 0 degree, and at theta equals to 180 degree there is no radiation. For Hertzian dipole it was same for lambda by 2 dipole as well, for half wave dipole as well. And it was same for, I guess, as far as I remember, it was same for full wave dipole as well. So this kind of patterns we were getting. That means in all the direction radiation was not equal. At theta equals to 90 degree you are having maximum, at theta equals to 0 degree, and at theta equals to 180 degree you are having no radiation at all. But there is a hypothetical antenna. This is not a practical antenna. Practically it is not possible, but there is a hypothetical antenna that we assume that it will have radiation equally in all the direction. That means if this is a point source, then it will radiate equally in the whole direction, that here, 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 and in 3D it will equally radiate. So this is what we assume. But a practical antenna, let's just say Hertzian dipole antenna, it will not radiate equally in all the direction. So this is a hypothetical antenna which is known as isotropic antenna. So if in your question isotropic antenna is written, then what you will think, that it is radiating equally in all the direction. So can you let me know one thing? Here the electric field will be a function of theta or phi? Will the electric field will be a function of theta and phi? No, because if the electric field is function of theta and phi, that means at different angle it will give different radiation. What I mean to say is that for normalized value of electric field for your Hertzian dipole, it was sin theta. That means your electric field was a function of theta, no? That's why we said that at 0 degree you are having 0 radiation, at 90 degree you are having maximum, and then again at 180 degree you are having 0 radiation. So if it was a function of theta or phi, that means it will have different radiation at different theta and phi. But here what isotropic antenna is saying, that it will give radiation equally in the all direction. That means it can never be a function of theta and phi. Are you getting this point? It can never be a function of theta and phi. What is P average? P average is E naught square by 2 eta. So eta can never be a function of theta and phi. If E theta s is not a function of theta and phi, that means P average can also not be a function of theta and phi. And now U theta, what is U theta? R square into P average. Here there is no vector sign. Radiation intensity is not a vector quantity. So R square into P average. So if this is not a function of theta and phi, then certainly R can never be a function of theta and phi. So if P average is not a function of theta and phi, that means this U theta comma phi can also not be a function of theta and phi. So what did you understand? Here U theta phi, here we have written radiation intensity as U theta comma phi, but it is not actually a function of theta comma phi. So can I write down my U theta comma phi as U average? So radiation intensity of a isotropic antenna is known as average radiation intensity. What I said previously, how did we start? We started with radiation intensity. We got to know that R square into P average is our radiation intensity, that is U theta comma phi. That is our radiation intensity. Then I told you about a hypothetical antenna that is known as isotropic antenna, which is radiating in all the direction equally. It is radiating equally in all the direction. So from there I go to know that my radiation intensity u theta comma phi will never be a function of theta comma phi. So it can never be a function of theta comma phi. It will be some quantity. It will be some constant quantity. So that I can write down as u average. Say yes or no. So if somewhere u average is written, so you would get to know that it is never a function of theta comma phi. So now we will find out the value of u average. What we are going to find out? We are going to find out the value of u average. So this is the concept that we need to find the value of u average now. So again, let's write down P radiated. So forget about this formula. So how will you write down P radiated now? You will remember that, sir, P average would come, then R square sin theta d theta d phi would come. This much you will be able to remember. Okay. Now P average into R square, what is that? U theta comma phi. That is your U theta comma phi. Sin theta d theta d phi. What is U theta comma phi? In this case, it is not a function of theta or phi. That means it can be taken outward, because here which limit you will write down? You will write down the limit of theta and you will write down the limit of phi here. So this is not a function of theta comma phi. It could be anything. It would be function of R, but it is not a function of theta comma phi. So we can take this out of the limit, and when we take it out of the limit, then it will become U average. Okay, so this is your average radiation intensity. Now we need to put the limit. So from where to where you will have the limit of theta? From 0 degree to pi. And from where to where you will have the limit of phi? From 0 to 2 pi. Here I should not write degree if I am writing in radian. Sin theta d theta d phi. And what is this? P radiated. This is U average. Now integration with respect to theta. So sin theta d theta. So integrating from 0 to pi and integrating d phi from 0 to 2 pi. What is the integration of this? You can do it, it will be 2. Okay. So U average, this is 2 and this is 2 pi. Because if you integrate this, you will get 2 pi only, and from here you will get 2, from here you will get 2 pi. So what you are getting, P radiated is equals to U average into 4 pi. So what will be your U average now? So U average is P radiated divided by 4 pi. A very, very important formula. So for any antenna, if I ask you what is the average radiation intensity, that is P radiated upon 4 pi. Look, this is the radiation intensity of isotropic antenna. But for any antenna, if I ask you what is the average radiation intensity, then it will be P radiated upon 4 pi. You are not understanding my point. What I am saying is that, let's just say there is a Hertzian dipole antenna, and I tell you the radiation intensity of Hertzian dipole antenna is U theta comma phi. Am I right? Yes. Radiation intensity of Hertzian dipole antenna is U theta comma phi. And if I ask you what is the average radiation intensity of this Hertzian dipole, that will be U average, and that would be equals to P radiated upon 4 pi. And if I ask you, this is your isotropic antenna. What is this? This is your isotropic antenna. So if I ask you what is the radiation intensity of isotropic antenna, that is equals to U average only. So this is just a base. Are you getting this point? Let's just say there is a class where some guy is getting 50 marks and other guys are getting 75 marks, 100 marks, and in that manner. So what you say is that, and some guy is getting 150 marks. So what you say is that this guy is getting minimum marks, 50 marks. So you make this as a base. So what this guy will say? That I am getting double of his marks. What this guy will say? That I am getting 1.5 times of this marks. And what this guy will say? That I am getting 3 times of this guy's marks. So in the same manner, for isotropic antenna is our base. That we have assumed that the radiation intensity of isotropic antenna we will be taking as a base, and that is equals to P radiated upon 4 pi. So you don't need to think all these things. If I ask you what is U average, so you need to tell it is P radiated upon 4 pi. And how we got here? You will understand, okay sir, P radiated is there, then U theta comma phi was there, that will come out, U average it will become, and if I solve the limit, what I will get? 4 pi. So P radiated upon 4 pi, that's it. Will that be clear to you? Like this also you don't need to mug up. In the mind only you can do the derivation. P radiated, from here I will get 4 pi, so P radiated upon 4 pi is our U average. Are you getting this point? So you have got U average formula, you have got the U theta comma phi formula. So let's write down a quick summary. Quick summary we will write down. So whatever that we have studied, because in this particular chapter there are a lot of formulas. So student usually get confused in this chapter that how much formula we need to remember. But we will always go with the first thing, that if nothing clicks to us, then I will start with P radiated. What is that? That is equals to P average into R square sin theta d theta d phi. From here I will get to know that what is my U theta comma phi, that is equals to R square into P average. This is the first thing I got to know. Then if I need to write down my P radiated, can I write it down in this manner, that it is U theta comma phi sin theta d theta d phi. Can I write it down in this manner? Certainly. Then we introduce another term, that is U average. So for U, what is U average? So for U average, this P radiated is there as it is. Now if I say U average, that means I will be taking this out. So my U theta comma phi is not a function of theta and phi. And if it is taking out, if it is getting out, what does that mean? That means, what does that mean? That means your U theta comma phi is not a function of theta comma phi, and it is your isotropic antenna. So it will become an average radiation intensity. So if you solve this limit, because the limit will be going from 0 to pi, theta will be going from 0 to pi and phi will be going from 0 to 2 pi. So if you solve the limit, you will get 4 pi. So what is my U average? That is P radiated upon 4 pi. From here, can you tell me the unit? What will be the unit? Unit of, this is your average radiation intensity. So here I am writing unit. So what will be the unit? What do you think? Unit is, what is the unit of P radiated? Watt. And what is this angle? Radian? No. This is a solid angle, no? So stay radian. This was a solid angle, no? You did the integration of a solid angle. So what will be the unit? Watt per stay radian. Same unit will be going for this guy as well. Because this is simply your, what is this? This is your radiation intensity. Although it is the average radiation intensity, and this is your normal radiation intensity. So this was radiation intensity, and this is also a radiation intensity, but it is average radiation intensity. So from this formula I got to know that unit is watt per stay radian. So similarly, unit of radiation intensity, what is the unit? That is watt per stay radian. This is the unit. So till now, only this much thing you need to remember. Is that clear to you? Is it that tough? No, certainly it is not tough. We need to start with P radiated. Then I got to know that this is U theta comma phi, and from there I got the formula of U average. So this is the short summary that we need to remember. Now we are going to understand two terms. So what is the first term? Directive gain. So we write it as directive gain. Directive gain. Directive gain. D for directive, G for gain. Directive gain. And it will also be a function of theta comma phi. Okay, this will also be a function of theta comma phi. So what is directive gain? So your directive gain is, what all two terms you have studied? What was the first term you studied? What was the first term that you studied? That was radiation intensity. And what is the second term you studied? Average radiation intensity. There you go. That's it. First term you studied radiation intensity divided by average radiation intensity. So can I write it down in this manner? What is U theta comma phi? Let's write down U theta comma phi as it is. What is my U average? That is P radiated upon 4 pi. P radiated upon 4 pi. U average is P radiated upon 4 pi. And this is for any antenna. If I ask you for Hertzian dipole antenna, what is your U average? What is your average radiation intensity? So what you will say? Sir, it is P radiated upon 4 pi. You will not say that, sir, U average is defined only for isotropic antenna. No. For isotropic antenna, U theta comma phi and U average both are same. What I mean to say is that I will write it down here. For isotropic antenna, U theta comma phi is equals to U average. So for isotropic antenna, U theta comma phi is equals to U average, and what is U average? That is P radiated upon 4 pi. So if I give you the value for isotropic antenna, if I say that radiation intensity is 4 watt per watt stay radian, then what is the power radiated by isotropic antenna? So can you find it out? Yes. What I have given, radiation intensity, what is that equals to? P radiated upon 4 pi. So what will be P radiated? 16 pi watt. That would be the answer. Very simple thing. Okay. So for isotropic antenna, what did you studied? That radiation intensity and radiation intensity and average radiation intensity both are equal thing. Is that okay for you? But this U average, it doesn't mean that it is defined only for isotropic antenna. It is defined for any other antenna, and for all the antenna, the U average is P radiated upon 4 pi. So for all the antennas, so U average is P radiated upon 4 pi. Okay. So if it is P radiated upon 4 pi, then this 4 pi can go upward. So what you are getting? U theta comma phi into 4 pi. So this is the other formula. This is the other formula of GD. So let's write down in a better manner. So this is U theta comma phi will remain there as it is. Then what will happen? U average is P radiated into 4 pi. So this you need to keep in mind, because U average will not be directly used. What that will be used is that U average is P radiated upon 4 pi. So this formula will be used more. So that's why I will put this in a complete box. Now let's solve this more. So this is my directive gain, which will be a function of theta comma phi. And why it will be a function of theta comma phi? Because this quantity will not be a function of theta comma phi. That will be a fixed quantity, right? This quantity will be a fixed quantity because P radiated will be fixed and 4 pi will be a fixed. So P radiated is never a function of theta comma phi. 4 pi is also not a function of theta comma phi because this is a fixed quantity. U theta comma phi is a function of theta comma phi. So that's why the directive gain is also a function of theta comma phi. So let's solve it more. So how you can write down U theta comma phi? That is R square into P average into 4 pi divided by P radiated. So from here I can find out P average. What that is? P radiated upon 4 pi R square GD theta comma phi. So I will tell you very interesting thing about this particular expression, but not as of now. What does this expression represent? How we will be using it? So this is also a very important formula, and you don't need to mug it up. As of now, you don't need to mug it up. You will be eventually remembering it, and how you will be remembering it, that also I will tell you. So, but as of now, you just see it that P average expression we have got, and if you need to derive it anyway, you can derive it. But eventually, you are going to remember it. Eventually, you are going to remember this formula, but not as of now. Now we have written directive gain. What is directivity? There is another term, that is directivity. So directivity is nothing but a maximum of directive gain. That's it. Directivity is nothing but the maximum of directive gain. So what is the maximum of directive gain? So what is your directive gain? Your directive gain is U theta comma phi. What maximum I need to calculate? I need to calculate the maximum of U theta comma phi divided by P radiated into 4 pi. This is a fixed quantity, this is a fixed quantity. So which maximum you are going to take? You are going to take the maximum of this one. Are you getting this point? This is a fixed quantity, this is a fixed quantity. You are going to take a maximum of this one. Now let us say my U theta comma phi is sin square theta. This is my U theta comma phi. I am assuming that my U theta comma phi is sin square theta. Then what will be its maximum value? 1. What I mean to say is that I am calculating the maximum value. That means it will be a fixed quantity, no? Right? If it was U sin square theta into sin cube phi into 1. So what will be its maximum value? That will also be 1. It could be 2 here. So what will be the maximum value? It could be 2. So maximum value could be 1, 2, 3, 4. It could be anything, but it will be a fixed value, right? So now what I will do is that I will write down maximum of U theta comma phi. That I am writing as U max. But here I am not writing theta comma phi. Why is that so? Because this is a fixed quantity and that will not be a function of theta or phi. That's why I am not writing theta comma phi here. Are you getting this point? Divided by P radiated into 4 pi. This is your directivity. So again, you feel like that, sir, there are a lot of formulas. This formula is there, this formula is there, these formula is there, but nothing, no formula is there. What you need to think that we will start from P radiated, P average into R square sin theta d phi. R square into P average is u theta comma phi. And we have defined another term that is known as U average, average radiation intensity, that is P radiated upon 4 pi. Then we went to our directive gain. What is that? Directive gain is equals to the U theta comma phi divided by U average. So what is U theta comma phi? U theta comma phi will be as it is. What is U average? U average is P radiated upon 4 pi. So that is my directive gain. And what is my directivity? Maximum of that. That's it. So maximum of U theta comma phi is U max. So what is your U max? U max is equals to maximum of U theta comma phi. Okay. So nothing is there. You feel like that it is a lot of things, but nah, these are not a lot of things. These are very simple formula, and I will relate everything. We will solve a lot of problems, like more than 10 to 15 problems we are going to solve in this particular lecture only. So do not worry about that. Fine. Yeah, sorry for the interruption. So what we were studying about directive gain and directivity. And previously we studied about radiation intensity and average radiation intensity. Now I will show you the meaning of directivity. Okay, and I told you one more thing, that you don't need to worry about all these formulas. These are very easy, very straightforward. We will start from P radiated and we will be able to write down all the formula. So do not worry about that. Now let's understand the meaning of this directivity. That is a very important term, and it will be used in a lot of questions as well. So let's understand the practical meaning of directivity. It might not be asked in your examination, but in the interviews certainly it can be asked. So what is this diagram? This diagram is copied from Bellani's book. So what does this diagram shows? So this diagram is showing the radiation pattern for different length of antenna. So this particular length which you can see, this radiation pattern you can see, that is for Hertzian dipole. This radiation pattern is for Hertzian dipole. Again I am writing Hertzian. So you understand this is Hertzian only. This is my habit. This is for Hertzian dipole. And the next one is for lambda by 4. The next one is for lambda by 2. The next one is for 3 lambda by 4. And the next one is for lambda. So what do you see? As the length increases, because Hertzian dipole will have the minimum length, it will be roughly around lambda by 50 I am writing. It would be anything. It would be very less than lambda. So Hertzian dipole will have the minimum length, then lambda by 4, then lambda by 2, then 3 lambda by 4, and then lambda. So as the length is increasing, the lobe width is getting smaller. What do I mean by lobe width? So let's just say this is my antenna. So it is having radiation pattern like this, and here also it is having radiation pattern like this. So this radiation pattern is similar to this one. Why is that so? Because certainly this range is from 0 to 180 degree. This range is also from 0 to 180 degree. So both will have the same radiation pattern. So I am only caring about this lobe. So this is known as lobe. This is known as lobe. And what do I mean by lobe width? This width. This width is known as lobe width. Okay. So as the length increases, the lobe width is getting smaller. And that means directivity is more. Because what does that directivity show? Directivity shows that, listen to the statement very carefully. Directivity shows that in the direction of maximum radiation, how much power is concentrated. Directivity shows the concentrated power in the direction of maximum radiation. What I mean to say is, let's just take the example of 2 lobes. I will take the example of 2 lobes. So this is your antenna. This is your antenna. For lambda by 2 length, this was the lobe you were getting. For lambda by 2 length. For lambda by 2 length, this was the lobe you were getting. And for lambda length, this was the lobe you were getting. For lambda length, this is the lobe you are getting. This is for lambda by 2 and this is for lambda. Where is the direction of maximum propagation? Sorry, where is the direction of maximum radiation? At 90 degree, right? In all these cases, the direction of maximum radiation is 90 degree only. It could be anything else as well. It is not necessary that it will always be 90 degree. It depends on the length. We saw that for 3 lambda by 2, it was something else. For 3 lambda by 2, it was something else. It was somewhat around 35 degree. So, but all these cases, the direction of maximum radiation is 90 degree. So, in the direction of maximum radiation, who will have more concentrated power? So, this is this lobe. This is the lobe for lambda and this is the lobe for lambda by 2. Now, I am saying that both antenna, lambda antenna and lambda by 2 length antenna, both antennas are radiating 50 watt power. Both antennas are radiating 50 watt power. Now, this 50 watt power is contained in these lobes. And for lambda antenna, the 50 watt power is contained in this lobe for lambda antenna. And for lambda by 2 antenna, the 50 watt power is contained in this lobe, in this complete lobe. Now let's take an analogy. Let's take an example of a room. There are two rooms. In one room there are 10 seats. In the another room there are 5 seats. So 5 guys will sit in the room having 10 capacity, and 5 guys will sit in the room having 5 capacity. So here there are 10 capacities and here there are 5 capacities. Here there are 10 capacities. So here also 5 guys will sit and here also 5 guys will sit. So here they have to be congested, right? But here they can sit freely. So if I go in this room and I stand here, I am standing here. I am going in this room of a 10 capacity and I am standing here. So for a particular seat I will see lesser guy. That means for 2 seats I will see only 1 guy. But here for every seat I will see 1 guy. So this room is more congested. So what I can say is that here I found the power to be more, kind of power. What I am saying is that both are radiating 50 watt power. Both antennas are radiating 50 watt power, but since the lobe width is smaller, so in smaller lobe width, power will be more concentrated. So towards the 90 degree, power will be more concentrated if the lobe width is small. So only you need to understand one thing, that smaller the lobe width, more the directivity. Lobe width is inversely proportional to the directivity. So directivity shows that in the direction of maximum propagation, how much concentrated power you will get. So what do I mean by that is that, what do I mean here is that this was your lambda, this was your lambda by 2. So if I keep my receiving antenna here, this was your transmitting antenna, this was your transmitting antenna, and this is my receiving antenna. Now I know that from transmitting antenna, I am receiving 50 watt power. Even if you take lambda by 2 length antenna or you take lambda length antenna, in both of the cases, transmitting antenna is radiating 50 watt power. But if I keep my receiving antenna here, then I will understand, then what I will observe? I will observe that for the case of lambda length, I was receiving more power, and for the case of lambda by 2 length, I was receiving lesser power. That means for lambda by 2 length, let's just say I am receiving 20 watt power, then for lambda length, I will receive 30 watt power. Are you getting this point? Both are radiating 50 watt power, but the receiver will receive different amount of powers. Why is that so? Because in the lambda length antenna, if you see the radiation pattern, you will feel that this is more concentrated towards 90 degree. So at 90 degree, if I am putting my receiver here, then for lambda length, for this particular, I am not sure what is the length of this antenna. I am not sure what is the length of this antenna. I am talking about the length of these antenna. That lambda by 2 length antenna is also radiating 50 watt power, and lambda length antenna is also radiating 50 watt power. But when at the same location I put receiving antenna, then for the case of lambda antenna I am getting more power, and for the case of lambda by 2 antenna I am getting lesser power. And why is that happening? Because the lambda length antenna is more concentrated towards the direction of maximum propagation. That means it is more concentrated towards 90 degree. And if it is more concentrated towards 90 degree, that means it is having more directivity. And if it is having more directivity, that means my receiver will receive more power. Is that clear? So can you tell me the relation between the directivities of Hertzian dipole, lambda by 4 dipole, lambda by 2 dipole, 3 lambda by 4 dipole, and lambda dipole? Can you tell me the relation? Yes, certainly I can tell the relation. What will be the relation? So here I will write down a few points. What all those points will be? Those points will be that directivity is inversely proportional to the lobe width. This is the first point. What could be the second point? That directivity of lambda length antenna will be greater than 3 lambda by 4, will be greater than lambda by 2, will be greater than lambda by 4, and it will be greater than Hertzian. Say yes or no. So what in the examination, what kind of question can be coming? That they will make radiation pattern of 3 to 4 random antenna. Like they can make this diagram only. They will make this diagram only, and they will ask you what is the relation between the directivity. So this they can ask, or they can take any other random length and then they can frame a question from there. Are you getting this point? Okay. Now answer one question. So this was the radiation pattern. This is the radiation pattern for a random length antenna that I don't know. So this is the radiation pattern for L1 length antenna, and this is the radiation pattern for L2 length antenna. Okay. This magnitude is 3 and this magnitude is 2. This magnitude is 3. How do you make the radiation pattern? You write down the magnitude, right? This magnitude is 3, this magnitude is 2 and this magnitude is also 3. Are you getting this point? This particular radiation pattern is for some other antenna and the other radiation pattern is for some other antenna. This one is for length equals to L2 and this one is for length equals to L1. Who is having, and lobe width is equal, that this lobe width and this lobe width all are equal. Who is having more directivity? Who is having more directivity? So it is more directed. This guy is more directed if lobe width are same. This lobe width and this lobe width both are same. So now you need to see who can propagate to the longer distance. That this guy can propagate till 2 only, but this guy can propagate till 3. So radiation can go till 3 here and here it can go till 2. So who will have more directivity? This guy will have more directivity, right? The L1 length will have more directivity because here the lobe widths are equal, but the radiation is going far. Here the radiation is going far. So that's why this will have more directivity. Now second question. If I place my antenna here, let's just say this point is theta equals to 90 degree. At theta equals to 90 degree, I place my receiving antenna. This is my receiving antenna. Now answer my question. At theta equals to 90 degree, I am placing my receiving antenna. So for which case I will get more power? For length L1 or for length L2? What I mean to say is that my transmitting antenna can have length L1 as well. It can have length L2 as well. If it was having length L1, then this was the radiation pattern. If it was having length L1, then this was the radiation pattern. And if it was having length L2, then this was the radiation pattern. Now I got to know that who is having more directivity? This guy is having more directivity because this is radiating far. This is radiating far away. Now the second question is, I am placing my receiving antenna at theta equals to 90 degree. So in which case I will receive more power? When the length is L1 or when the length is L2? Tell me your answer. The answer is when the length is L2. But sir, you just said that the directivity of L1 was more than L2. But how you are receiving more power than at theta equals to 90 degree from L2? Because you need to see at that particular angle now. At theta equals to 90 degree, who is radiating more power? At theta equals to 90 degree, this is radiating lesser power and this is radiating more power. So the directivity always shows the direction of maximum radiation. That means if you put your receiving antenna here and another receiving antenna you put here, so in this case you will get more radiation at this particular place. That means let's just say this angle is some 45 degree. So for length L1, if you need to receive maximum power, then you need to place your antenna at theta equals to 45 degree. But for length L2, if you need to get the maximum power, then you need to place it at theta equals to 90 degree. So if I placed it at theta equals to 90 degree, I am getting more power. Why is that so? Because at theta equals to 90 degree, L2 is giving me more radiation than L1. Overall, L1 is giving you more radiation. But at that particular place, at theta equals to 90 degree, who is giving you more radiation? L2 is giving you more radiation. So that's why if I place my receiving antenna at theta equals to 90 degree, then I will receive more power, or I will have more power for the case of L2 length, because L2 is giving me more power at theta equals to 90 degree. Very simple point. I hope the actual meaning of directivity is clear. So directivity shows the maximum radiation, or you can say how much concentrated is your radiation in a particular direction or in the direction of maximum radiation. But what your directive gain shows, this is your directive gain, that in any direction how much concentrated is your power. So here I need to check my directive gain, that at theta equals to 90 degree, my directive gain at theta equals to 90 degree for the case of L2 will be more than directive gain at theta equals to 90 degree for the case of L1. Say yes or no? Because directive gain tells the maximum radiation but at a particular angle, but directivity tells the maximum radiation or concentrated radiation at the direction of maximum radiation. I hope these points are clear. I hope you are not getting confused, and I hope the concept is clear. There is very rare chance that question would be coming from the examination on this particular topic, but if they want to frame a good question, then they can certainly frame a good theoretical question based on the concept of directivity. So I hope I have cleared the actual meaning of directivity, and also I have cleared the meaning of directive gain as well. So if they want to frame a very good question, then they can certainly frame a very good question from this particular concept, or these kind of questions certainly can be asked in your interview as well. Is that clear? Okay then. So now next book गिर गया यार. And let me pause the video. Yeah, so I am back. Now we will see a very important point, but before that I wanted to add a point that here I wrote down lobe width. No, so in the textbook you will find this word to be as beam width. You can write down as beam width as well, or you can write down as a lobe width as well, but more better name is beam width. So beam width is nothing but that lobe width only. That means this width will be your beam width. Okay, so you can write down anything, beam width or lobe width. Okay, now let's see a very important point. What you need to find? You need to find a time average pointing vector or or power density at a distance r from the antenna. So this is your antenna, this is your source, which will give, let's just say this source is giving some P in power. Now there will be some losses. Till now what we have seen is that whatever the power this source is giving, the all power will be radiated by the antenna. But this is not true. Whatever the power this source is giving, let's just say this source is giving some P in power. So all the power will not be radiated by antenna. There will be some losses as well, and that losses we will see. So as of now, don't worry about that. What I am saying is that the power radiated by antenna is P radiated. Forget about this relation between P and P radiated. That relation we will see. So your source is giving P in power. The power radiated by the antenna is P radiated. So at this particular point, it is radiating P radiated power. So what will be the time average pointing vector P average at a distance r from the antenna? So you already know this formula. Let me know what is this formula. Do I know the directive gain? Yes. What is the directive gain? That is u theta comma phi divided by P radiated into 4 pi. Radiation intensity divided by average radiation intensity, which is P radiated upon 4 pi. So this will be the formula that will be highly used. But this is not our conclusion. From here, what I can write as u theta comma phi. What is my u theta comma phi? U theta comma phi is r square into P average. So from here, what I am getting, my P average is, so P average will be, what power is radiated? P radiated divided by 4 pi r square. You can assume as a area of a sphere. P radiated upon 4 pi r square. Just remember to multiply with the directive gain. That's it. There you go. From an antenna, P radiated power is being radiated. Now I am asking, at a distance r, what will be your P average? What is the unit of P radiated? Watt. How much power is radiated? What is this? Time average pointing vector or power density. So what is the unit here? Watt per meter square. We spent a lot of time between P average and P in when we were studying about EM waves. So in EM waves, I made a separate lecture on pointing vector. So there I taught you about time average pointing vector. We studied about P in. Then so what is the meaning of power density, and then we related it with our EM wave. So we have spent a lot of time. So I hope it is clear that P average will have a unit of watt per meter square and P radiated will have a unit of watt. And from here as well, you can verify what is your P radiated, that is watt per meter square, because r square will have a unit of watt per meter square. And what about GD? U theta comma phi divided by U average. So this is unitless. I forgot to write here. This is unitless. Why it is unitless? Because this is watt per stray radian. This is also watt per stray radian. Both will be cancelled. Watt per stray radian divided by watt per stray radian. Both will be cancelled. Unitless. So better you should write unitless. Same goes here. This is also unitless because this is nothing but the maximum value of this. So this is also unitless. Or we can show it in dB. Sometimes we can show it in dB. Let's just say directivity is 10. Then how will you show it in dB? 10 log 10 into 10. So 10 dB. So these kind of questions we will see there, it will be more clear. Okay. So if you need to show it in dB, then how will you show it? Tan log tan, and whatever the value that you are getting, this will be in dB. Okay, and if you need to show this one, then how will you show it? Tan log tan d, this will be in dB, because all these terms are associated with power. This is also associated with power only. You can see power term, so that's why tan log tan. If it was voltage or current, then 20 log tan would be coming, 20 log tan would be coming, but all these terms are associated with power, so tan log tan, tan log tan. Okay, so where were we? Yeah, so P average we were calculating. So from an antenna, if power radiated is P radiated, then at a distance r, how much time average pointing vector I will get, or how much power density I will get? What is that? P radiated upon 4 pi r square into GD theta comma phi. So how do I actually remember it? P radiated, I write, okay, this much power is being radiated, then at the distance r, okay, then what is the formula of surface area of sphere? Surface area of sphere, that is 4 pi r square. So P radiated upon 4 pi r square, I never forget to multiply by GD. GD of what? GD of this one. What is GD? Directive gain of this antenna. Directive gain of this antenna. And can I call it transmitting antenna? What I am calling it? I am calling it transmitting antenna. Transmitting antenna. So receiving antenna will also come into action when we study about Friis equation. So at that time, all these things will be used. So GDT I am writing. This is your transmitting antenna. Okay. So all these formulas are used when we study about Friis equation. So now it will be very easy. Friis equation will be very easy, because we will break down Friis equation in a lot of concepts. Okay. So when we go to the Friis equation, we would have already studied Friis equation. So this is how we are going to study. So whatever that we have studied till now, we are going to write down summary of everything. From where did we start? The first thing is, this is your P radiated. From here you need to start. P average into r square sin theta d theta d phi. There you go. From here what you get to know is that u theta comma phi is your r square into P average. So from here P radiated you can write down as u theta comma phi sin theta d theta d phi. One term I decided, that is was u average. So in case of u average, what will happen? This will come out, right? U average is defined for any random antenna as well. So for any random antenna, what is the average radiation intensity? That is P radiated upon 4 pi. And how did we derive it? We took the base of our isotropic antenna. We told that in isotropic antenna, what happens is that it is radiating in same direction. It is radiating same in all the direction. That means its radiation intensity is not depending on theta and phi. It is radiating everything same in all the direction. So if it is not depending on theta comma phi, that means it can come out, and from there we get that P radiated upon 4 pi is our u average. This is our u theta comma phi. Right? Now what is next? This is u theta comma phi we have got, u average we have got. So second thing we studied about directive gain. What we studied? Directive gain. What was the unit? Watt per steradian. This unit was also watt per steradian. Then we studied about directive gain. So what was directive gain? Ratio of those two things that we studied, u theta comma phi divided by u average. But this is not the more famous formula. More famous formula is u theta comma phi divided by P radiated into 4 pi. This is your directive gain. Then what is the third thing I need to remember? Directivity. Directivity is nothing but the maximum value of our directive gain. Directive gain, maximum value of our directive gain. And what is that? Maximum value of radiation intensity divided by average radiation intensity, which is P radiated into 4 pi. And what was the fourth formula that we studied? That if I need to find out P average at a distance r from the antenna, then that would be P radiated divided by 4 pi r square into, I will never forget to multiply the directive gain. So is it tough? Absolutely not. Like mostly what happens is that a lot of formulas are taught, they will write down this formula, that formula, and then eventually student mess it up. They will feel like that antenna is tough. But no, we have seen the practical meaning of directivity as well. We have seen all these terms as well. So only this slide should be in your revision, or this will be your short notes. That's it. Now what we need to do? We need to solve the problems. What we are going to do? We are just going to solve the problems. So I will take a break. You try solving these problems. You can certainly solve these problems. So I will take a break after solving one problem. So I will solve this question, then you can try other problems. Okay? Because these are very easy. What we need to find? Directivity. So what is directivity? U max, maximum value of this guy, divided by P radiated into 4 pi. Say yes or no. Can I write down U max from this equation? Yes. What will be my U max? Look, here you don't need to apply any sinusoid or cosinusoid relation. Why is that so? Because this is having other limits. This function is having the limit of theta, and this function is having the limit of phi. So theta is from 0 to pi, and theta is from 0 to phi. Theta is from 0 to pi, theta is from 0 to pi, and phi is from 0 to pi. Both are from 0 to pi only. So this is your sin theta from 0 to pi. What will be the maximum value? 1. So maximum value will be 2, they will be there as it is. What is the maximum value of sin theta? That is 1. And what is the maximum value of sin cube theta? That is also 1. So yeah, that's the answer. U max is 2. So U max you already know. Now what is the task that you need to find? That is P radiated. So what I need to find? I need to find P radiated. This is the best way of solving any question based on antenna. What you will write down? That what I need to find? I need to find the directivity. So what I will write down? U max divided by P radiated into 4 pi. So I need to find the directivity now. U max I already know. Now what is the task? P radiated. So what is the basic formula of P radiated that we know? Before this lecture, what you know? That was, sir, P average into R square sin theta d phi. But sir, what is this? This is U theta comma phi. This is your U theta comma phi. So can I write down on the next page? Yes. What will be my P radiated? Sir, what is my U theta comma phi? 2 sin theta sin cube phi. Then after that what will come? Sin theta d theta d phi. What will be the limit of theta? So limit of theta you will not put blindly that it is from 0 to pi. First you need to see here. What is the limit of theta? This is the limit of theta. Okay. So limit of theta is from 0 to pi. And what is the limit of phi? Limit of phi is from 0 to pi as well. Usually our limit of phi is from 0 to 2 pi. But here we will take a limit from 0 to pi only. Why is that so? Because it is given, no? They have given the limit till pi only, so you will take limit till pi only. What do they mean is that your antenna is radiating from theta equals to 0 to pi, and it is radiating from phi equals to 0 to pi as well. But usually what we assume is that our antenna will radiate in a complete sphere. But this is not complete sphere, right? Your phi is going from 0 to pi only. So this is a hemisphere. This is not a complete sphere. This is a hemisphere. Hemisphere like this. That phi is going from 0 to pi only. So till this point it is going. So it is a hemisphere like this. It will be a hemisphere like this. So if you take this globe, so only the half part of this globe, because phi is going from 0 to pi only. So you don't need to study, you don't need to think about the radiation pattern. What I mean to say is that you have the radiation intensity, then see these limits, put the limit and just solve it. So what you are going to get? If I solve the limit of sin theta, that is sin square theta d theta. If I limit the limit of sin cube phi d phi, this is from 0 to pi and this is from 0 to 2. Okay, 2. Can you let me know what will be the answer of this one? Yes. How will I solve it? You can solve it by simple mathematics or anything, but which formula I have taught you? In the first lecture I told you a mathematical formula. What is that? That you need to see this term 2 minus 1, then 2 minus 3, that I am not going to do, divided by, start from here, 2 into 2 minus 2, 0 I am not going to do. I hope you remember this formula. Sin m theta cos n theta d theta. Limit is from 0 to pi by 2, and then some formula I taught you, right? So that that formula I am applying. But the limit is from 0 to pi by 2. But here the limit is from 0 to pi. In our formula, the limit is from 0 to pi by 2. You can solve it by simple mathematics as well. But if you apply that formula which I have taught you, then you can solve in this manner. So limit is from 0 to pi here. But in our formula, the limit is from 0 to pi by 2. So from 0 to pi, sin square theta will be positive only. So whatever that is happening for 0 to pi by 2, same thing will be happening for pi by 2 to pi as well. So what I can do, I can multiply with 2 as well. Are you getting this point? So this will be the answer. But along with that, what will come? Since it is a even value, so pi by 2 will also come. And what about this? Did I ask you to remember the answer of this one? Yes, because it will be again and again used. So 0 to pi sine cube phi. What will be the answer? 4 by 3. So this integration you can do on your own. But I have also taught you that how to solve these kind of problems. And for this one, I told you to remember the answer. What was the answer? 4 by 3. And this one you can solve 2 minus 1 divided by 2 into 2 as well, because the limit is from 0 to pi by 2. So double, since it is an even value, so into pi by 2 will also come. That's it. This is the answer. So what I can see, 2 and 2 is getting answered, 2 and 2 is getting answered. So 4 pi by 3. So my P radiated is 4 pi by 3 watt. So what is directivity? Directivity is U max, that is 2 into 4 pi divided by what is P radiated, 4 pi by 3. So directivity is 6. That's it. This is the answer. Very easy question. Now the next question that you need to do on your own. I will take a pause. You can try doing it on your own. What is the thing that you need to notice here? That is, the limit of theta is changed from 0 to pi by 6. The limit of theta is changing from 0 to pi by 6. In the previous question, it was from 0 to pi. Now it is from 0 to pi by 6. Okay. So try solving it on your own. Use your brain. Okay. So I will take a pause. Then I will come back. Yeah. So let's try now. So I hope you must have solved the question on your own. Now we will do the solution. So what we need to find? We need to find the directivity. So what is the formula of directivity? U max divided by P radiated into 4 pi. This is what we need to find. And what is the value of U max here? So U max directly we can see here is that U max is, yeah, you tell me what should be the value of U max. So what is the range of phi? So what is the range of theta? Theta can go till pi by 6 only. So if I draw the graph of sine theta, so sine theta cannot go till pi by 2. If theta could go till pi by 2, then sine theta would have a maximum value as 1. But it is going till pi by 6 only. And what is the value of sine pi by 6? That is half. So you need to always see the range. Are you getting this point? So maximum value is sine pi by 6, and here you can take sine cube. So you can take pi by 2. So this is the maximum value of sine cube phi, but this is the maximum value of sine theta, because the range is till pi by 6 only. You are not even reaching pi by 2. If you are reaching pi by 2, then it was fine. So maximum value is sine 30, sine theta is 1 by 2 only. So answer is 1. So this is the maximum value. Maximum value is 1. So this was a catch here. Now P radiated I need to find. So what is my P radiated? So for P radiated, I will put the limit of theta. Theta is going from 0 to pi by 6, and I will put the limit of phi as well. Phi is going from 0 to pi. And then U theta, that is 2 sine theta, sine cube phi, and then sine theta, d theta, d phi. Right? So what I can do is that let it be like this only. So from here, 2 I can take outward, 2 I can take outward. Then I need to integrate sine square theta, sine square theta, d theta. Limit being from 0 to pi by 6, and then I need to integrate sine cube phi, d phi. Right? Sine cube phi, d phi. Okay. I know the answer of this one. What is this? This is 4 by 3. This is 4 by 3. So I know the answer of this one already, but this I need to integrate now. So what I can do is that 0 to pi by 6. What I can apply? I can apply the formula of cos 2 theta divided by 2 d theta. And this answer I already know, that is 4 by 3. So this 2 and 2 is getting cancelled. Here I am getting 4 by 3. 4 by 3, and then I need to integrate this one. So what I will get? 2 and 2 is getting cancelled. So here I am getting theta minus sine 2 theta divided by 2, 0 to pi by 6. Because differentiation of cos is minus sine, so integration is plus sine. So yeah, now I just need to put the limit 4 by 3. If I put the limit 0, everything will be 0 only. And if I put this limit, so 4 by 3 minus pi by 6, then sine pi by 3 divided by 2, right? So in pi by 3 is sine 60 degree. So here I can write down sine pi by 3 in a better manner, sine pi by 3. Okay, so what will be the answer you will be getting here? So sine 60 divided by 2 minus pi by 6 plus minus into 4 by 3. So 0.120, almost around 0.12. This is the P radiated we are getting. This is my P radiated. So what is my directivity now? 4 pi into U max. So 4 pi into U max is 1 divided by 0.12. So what you are getting? Reciprocal of this into 4 into pi. So 104.04. Okay, so this is that directivity. This is the directivity we are getting, that is 104.04, and you can find it in dB as well. So if you need to find it in dB, directivity in dB, then what you need to do, 10 log 10 104.04. So if I take log 10 into 10, so that is 20.17 dB. So this could also be one of the answer. Better chances are there that this should be mentioned. Usually directivity is mentioned in dB, in decimal. Okay, this was easy question. Just just the thing was the limit. So here maximum value would not be 2, it would be 1. So here I will star mark it. So when you revise this question, you just need to see this thing. That's it. Next question is also very easy. Try it on your own. Like 100% all the students should be able to solve these kind of problems. And from where we are picking these questions? So the previous question was from Sadiku. Some questions we are taking from Balanis, and some questions we are taking from Cheng. So these are solved unsolved question of these three textbooks. So these three we are following. Certainly we are not going to cover up everything that is there in Balanis. We are certainly going to cover up everything that is there in Sadiku, and most of the things of Cheng also we are going to cover up. But Balanis is a separate book. It is only for antenna. So certainly we cannot cover everything that is there in Balanis because it is very vast book. Okay. So yeah, it is like of roughly around how many pages are there, that I will see later on, but it is a very vast book, and to be very honest, I never studied this book completely. Okay, I have never studied Balanis completely, so I can neither say that I know the book pretty well, but no. But most of the things of Sadiku we have done, complete book we have done. Apart from that electron stats and magnostats part, those are not in our syllabus, and most of the part of transmission line we have done from Cheng. Okay, so for transmission line, this is very good book. So these we are following for antenna. So like you can see, these are the screenshot directly from the book only. So you need to solve this question, directivity. So maximum value till pi by 2 it is going, so maximum value will be 1. There is no value of phi here. U theta comma phi is not a function of phi, so don't care about phi. What about theta? Theta is going from 0 to pi by 2, so maximum value will be 1. So what is your U max here? U max is 1 only. I am not writing down the formula because I know that what I need to find. I need to find directivity. So what is my directivity? I usually remember the formula by U max divided by P radiated upon 4 pi. So this is how I remember, U max divided by P radiated upon 4 pi. So this is not written in a good manner. So U max divided by P radiated into 4 pi, right? And can you write down P radiated very quickly? Yes. What I need to do? I need to integrate theta from 0 to pi by 2 and phi from 0 to 2 pi. Then what will happen? Sin theta into sin theta d theta d phi, right? So sin square theta, taking the limit from 0 to pi by 2, sin square theta d theta, and then 0 to pi d phi, because there is no function of phi, so 0 to pi d phi, that will be 2 pi only. Okay, so what will be the answer for this one? So answer for this one would be 2 minus 1 upon 2 into pi by 2 into 2 pi. Okay, so 2 and 2 is getting cancelled. So what we are getting? Pi square by 2, right? 2 and 2 is getting cancelled, pi square by 2. Yeah. So from here what we are getting? Directivity is 4 pi divided by pi square by 2. So 8 by pi 2.546. So at least this question you should be able to solve. If you are not able to solve this one after the previous two analysis, after these two analysis, then there is an issue, because this was totally based on the same concept. Here what they are asking, determine the electric field intensity at a distance of 10 km from an antenna having directive gain. It is not directivity, having directive gain of 5 dB radiating total power. So I always told you one thing, whatever that is given, that you need to write down. So what all things are given? P radiated is given, that is 20 kilowatt. What else is given? Distance R 10 kilometer is given, or better I would write down 10 to the power 4 meter, right? Okay, and directive gain is given, directive gain, that is GD, that is 5 dB. So this is given, so that means this is given in dB. So if you need to write down in decimal, what that would be? So that would be 10 to the power 0.5, right? So this GD would be 10 to the power 0.5. Are you getting this point? 10 log 10 GD is 5 dB. So from there you got the value of GD in decimal, that is 10 to the power 0.5. Is that okay for you? So these things are given. What we need to find? Electric field intensity at a distance. At that we need to find. So what did I tell you? That from an antenna at distance R, what I can find? At distance R, if I know the P radiated, then at distance R what I can find? P average I can find. And what is that P average? How do we find it? Sir, P radiated divided by 4 pi R square, because of the complete hemisphere. Sorry, complete sphere, not hemisphere, sorry. Complete sphere, because of the complete sphere, P radiated upon 4 pi R square into, I will never forget multiplying this GD. Now what is this P average? P average is electric field intensity square divided by 2 neta. Because what I need to find? I need to find electric field intensity. So E square by 2 neta, right? E square by 2 neta is equals to P radiated. This will be the formula. And this is in the air. So no medium is mentioned. So I will take neta value to be 120 pi, right? So everything is given. I just need to apply the formula and that's it. That would be it into GD. So here what is neta? Neta is 120 pi. So this thing is also given. So from here I will find out the value now. So P radiated is 2 into 10 to the power 4 into P radiated 2 into 10 to the power 4. What is GD? GD is 10 to the power 0.5 into 2 into neta, that is 120 pi, divided by 4 pi and R square 10 to the power 8. This is your E field, right? P radiated I have written 2 into 10 to the power 4 into GD. What is GD? 10 to the power 0.5, okay, into 2 into 120 pi divided by 4 pi divided by R. R is 10 to the power 8. Well and good, okay. So from here I will get the value of E. So let's check what value we are getting. So how I will solve it? This and this will get cancelled. Here I will be getting 30. If I cancel these two, then I will be getting 30. But let's not do it. So this will be 60. This would be 120. 120, and this is 10 to the power 0.5. 120 into, what we are getting is that 120 into 10 to the power minus 3.5, because this is 4.5, 4.5 minus 8, that would be minus 3.5, right? So what I can write down? 120 into 10 to the power minus 0.5 into 10 to the power minus 3. This I can write down. minus 3. So 0.5 plus minus so 37.94 millivolt per meter. So this is the value of E field. Okay, 37.94 millivolt per meter. So this was an easy question only, right? Let's go to the next one. So before going on to the next one, I will tell you a concept, that is efficiency of an antenna, but I need to pause the video because of the cough. So I will pause the video, then I will come back. Okay, so now we will start studying about efficiency of antenna. So what do we do in efficiency? What do I mean by that? So we will have a source. In antenna, what did we study? We will first have a source, then we will have a transmission line, and then we will have the arms of antenna, right? So let's just say from here, this is my source, this is my V in. So from the source, P in power is going. So how much power will be radiated? That would be P radiated. So till now what we were assuming, that I told you, we studied the concept of radiation resistance. So at that time what did we do? That sir, I will replace my antenna with R radiated. I will replace my antenna with R radiated. There will be transmission line. I will replace my antenna with R radiated, and then from the source, sir, whatever that power that is coming, the complete power is dissipated in the resistor, and whatever the power that is dissipated in the resistor, the same power is radiated by the antenna. This is what we were saying. So complete P in power was reaching this R radiated, but actuality is that the complete power will not reach this R radiated. Why is that so? Because there will be losses. And what kind of first loss will be there? You can directly see, this is your Z0. This transmission line will have a characteristic impedance as well, no? Z0. So if it is having Z0 impedance, that means it will have some reflection. What will be the reflection? R radiated ZL minus Z0 upon ZL plus Z0. And if it is having some reflection, that means there will be some power reflected and some power will be transmitted. And how much power will be transmitted? This much power will be transmitted. And how much power will be lost? Gamma square P in. This much power will be lost. So if P in is coming, then total power will not be radiated. Some power will be lost. So P radiated would be equals to neta into P in. And this is known as efficiency. Efficiency is shown by neta. Now in this neta, a lot of factor can come. This was one of the factor. Which was one of the factor? This reflection. So reflection loss. Now transmission line is made of what? Conductors. And in between there is dielectric, right? If you remember, in between there is dielectric and transmission line is made of conductors. So there could be conducting loss as well. And since there is in between dielectric, so there could be dielectric losses as well. So there could be conduction losses, there could be dielectric losses. So a lot of kind of losses could be there. And then because of these losses, some power will be remaining in the transmission line, or you can say reflected, and some power will be transmitted. So that much power that is reaching here, that much power will be radiated. Are you getting this point? So let's solve some questions. Let's solve some questions based on that. From there, concept will be more clear. So as of now, from this slide, what you need to learn is that if we are giving P in power, then complete P in power is not taken by the antenna. Some power will be lost because of the losses and reflection. There could be different kind of losses, conduction losses, dielectric losses, other losses can also be there, and one will be the reflection losses as well, because some power can be reflected back as well. Let's take an example, it will be more clear to you. So what they are saying, this is a lambda by 2 length antenna is there. The input power supplied is 10 watt. From here, 10 watt power is supplied. The characteristic impedance of the transmission line is 50 ohm. This transmission line is having a characteristic impedance of 50 ohm. Find the power radiated. Power radiated you need to find. So 10 watt power is coming. This is my transmission line. This is my transmission line. From here, now concept of transmission line should be clear. Then only you will be able to understand. 10 watt power is coming. This transmission line is lossless. Okay, it is not mentioned somewhere. Lossless transmission line means these conduction losses and dielectric losses are not there. These dielectric losses and conductance, this conduction loss and dielectric losses are not there. That means complete 10 watt has reached here. From here we go to 10 watt and complete 10 watt has reached here. Now the thing is, this particular antenna, this can be replaced with its Z-in, right? This antenna can be replaced with its Z-in. So it will be replaced with its some Z-in. And what is that Z-in? For lambda by 2 length antenna, what is the value of Z-in? That is 73 ohm? No. 73 plus J 42.5. Here what you need to find? You need to find the reflection coefficient. I hope you must have understood the concept. Let me make the diagram better. We are solving the question. So this is our transmission line having intrinsic, sorry, not intrinsic, having characteristic impedance of Z0, that is 50 ohm. From the source 10 watt power is coming. Since it is lossless, so 10 watt power has reached here. But this 10 watt is not supplied to the load. What is our load? Our load is antenna. Our load is the arms of antenna, which we are showing as Zin. And what is the value of Zin? Value of Zin is not 73 ohm. No, it is not 73 ohm. Why is that so? Because 73 ohm only the radiation resistance. I told you what is the input value, that is 73 plus 42.5 ohm. So now this 10 watt power will see that there is a mismatch between ZL and Z0. That means there is some reflection coefficient, and if there is some reflection coefficient, that means some power will be reflected back and some power will be transmitted. So for that, what I need to find? Reflection coefficient. ZL minus Z0 upon ZL plus Z0. So that I need to find now. So 73 plus J 42.5 minus 50 upon 73 plus J 42.5 plus 50. So what will be the reflection coefficient? I guess I already know the answer. I will see it somewhere. It is there somewhere in this. So let's not waste some time. I guess it was here only. Yeah, 73 plus J. This calculation we have already seen as well. So 0.27. I just need the magnitude. I don't need the angle. So what we are getting? Okay, this was for 75. Okay. This was for 75. This was not for 50. So this calculation I need to do. So let me pause the video because this calculation will take a bit of time. You can also do the calculation, right? 73 minus 50. 23 plus J 42.5 divided by 123 plus J 42.5. What I need to do? I need to take the magnitude now. This was the simple thing, 23, and now I need to take the magnitude. So I will take the magnitude. So this magnitude is coming out to be 0.371. Now if I need to find the P radiated, so what will be the power radiated? That will be, what is the loss? Loss will be somewhere else. That loss I don't need to care about. So power radiated will be 1 minus gamma square into P in. So I need to take the square of it, then minus 1. So 0.862 into P in. What is P in? 10 watt. So what will be the answer? P radiated would be 8.62 watt. 8.62 watt. So from here 10 watt power started working. Till this point it was 10 watt only, but at the load there was mismatch. Because of the mismatch there was reflection, and because of the reflections this much power is radiated, and the lost power, what is the lost power? 8.62 minus 10. So the lost power is 1.38. So 1.38 watt power is reflected back. So that is lost, and antenna is radiating 8.62 watt power. Very easy question, right? Now we will see another kind of loss, that is the conduction loss. It could be, or it could be dielectric losses as well. So what they have given is that the power supplied is 10 watt only. Power supplied is 10 watt. Now they did not mention about Z0 or Zin, anything they did not mention. They did not even mention the value of Z0. That means there is reflection losses are not there. There is no reflection losses. But what they have mentioned, the loss resistance of the transmission line is 27 ohm. What they have given? Loss resistance RL they have given as 27 ohm. Loss resistance they have given. What is the power radiated by the antenna? So what will happen is that there will be some power P in. Some power P in will be supplied. So that P in power will result in two things, that some power will be lost and some power will be radiated, right? P in will be resulting in two things, some power will be lost, some power will be radiated. So what is your P in? I naught square. Let's take P in as P in only. Let's take P in as P in only. So what will be your lost power? That would be I naught square by 2 into loss resistance. And what will be your radiated power? I naught square by 2 into R radiated. Here I am not writing Z in. Here I am writing R radiated only. Because what I need to find? I need to find the radiated power. And radiated power will be equals to the power dissipated. And whenever power is dissipated, that is dissipated in resistive part only. Here what I was finding? Deflection coefficient. So whenever we find reflection coefficient, so we write down the complete impedance. It's not that if impedance is R plus jx, so I write down only R part. No, whenever I find reflection coefficient, I write down the complete part, R plus jx. But if I am finding the power dissipated or power radiated, then I only need to take the resistive part. Is that clear to you? Okay. Yeah. Now what I can do is that I can write down the P radiated equation. What is P radiated? P radiated is I naught square by 2 into R radiated, right? This is my P radiated. Now what I can do is that what I can find P radiated divided by P in. P radiated divided by P in. What that would be? P radiated is I naught square by 2 into R radiated divided by, what is your P in? Your P in is I naught square by 2 into RL plus R radiated. So what you are getting? P radiated is equals to R radiated divided by RL loss resistance plus R radiated into P in. So from now onwards you need to remember this formula. Okay, very easy. Just if loss resistance is given and radiation resistance is given, then what you need to think that this transmission line is like a resistance. This transmission line is like a resistance of 27 ohm, and this is a resistance of, what is the radiation resistance of lambda by 2? That is 73 ohm. So like a resistance you need to take, and now you don't need to divide the potential, you need to divide the power. So how will you divide the power? P in into 73 divided by 73 plus 27. This is what we are doing. So this is just a way to remember. Okay, I will treat the transmission line in my mind, in the back of the mind, I will treat the transmission line as 27 ohm resistance, and now I need to divide the power. So P radiated will be 73 divided by 73 plus 27. So what will be the answer? P radiated, that would be equals to radiation resistance, that is 73, 27 plus 73 into P in, that is 10 watt. So what you are getting? 7.3 watt. That's it. This is your P radiated. So did you understand? These two kind of losses could be there. This was the reflection loss, and here it could be conducting loss, it could be dielectric loss, or it could be anything. So they have given a loss resistance completely. The loss resistance is 27 ohm. Now both of the losses can also be together. In this question, both losses are there together. Which two losses? Loss resistance is also given, and along with that, characteristic impedance is 50 ohm. So reflection loss is also there, and because of the conduction loss or because of the dielectric loss, that loss is also there. So two kind of losses are there. So what do you think? What will be your P radiated? So both losses you need to take in action. Which is the first loss? 1 minus mod of gamma square. And what is the second loss? R radiated upon R radiated plus loss resistance into P in. So what was the value for this one? 0.862. 0.862. And what was the value for this one? 0.73 into P in. What is P in? 10. So what is P radiated? 0.862, 0.73. So that is coming out to be 62.93 watt. There you go. This is your P radiated. Very, very easy, right? So needlessly, we are not getting confused between the formulas, because I have seen a lot of formulas are taught in this particular concept, that this formula is for that efficiency. No, nothing like that. Don't get confused in formulas. Better understand this concept with the problems, that what kind of losses are there. Always you will make a diagram. If you feel like that only statements are given, so in the back of the mind you can make the diagram, or in the examination as well you can make this diagram. It will take hardly 10 seconds. So you can make this diagram, then you will know, okay, reflection is also there, loss is also there. So in that manner I can proceed with my question. Very easy. Let's go to the next concept. So what is power gain? There is another term, that is power gain. So what is power gain? Till now what all terms we have seen? Radiation intensity. You know what is radiation intensity? R square into P average. Then average radiation intensity, P radiated by 4 pi. Then we studied about directive gain. So what is directive gain? U theta comma phi divided by U average. What is your directivity? Maximum value of directive gain. What is power gain? Power gain is efficiency into directive gain. That's it. This is what they are asking. This is your power gain, nothing else. Just your directive gain multiplied with the efficiency. That would be your answer. Is that okay to you? Okay. Let's see the next question. A lossless resonant half wavelength dipole antenna with input impedance of 73 ohm is to be connected to a transmission line whose characteristic impedance is 50 ohms, assuming that the pattern this is given. What is given? What is this? Assuming that the pattern of antenna is given approximately like this. U is given. What is U? Radiation intensity is given. So what I need to find? I need to find the overall maximum gain of the antenna. What we need to find? Overall maximum gain of the antenna, and also I need to find half power beam width. So what is given? U theta comma phi, B naught sine cube theta, B naught sine cube theta. So this radiation intensity is associated with power, no? This is nothing but it is term of power only. What is radiation intensity? R square into P average. So it is associated with power only. Now if I need to find half power beam width at half power, or what I need to write is that at half power, the value of U theta comma phi would be half of its maximum value, because it is associated with power only. If it was associated with the electric field, then I would have said that at that point it would be E naught by under root 2. But at half power, what will happen? Half of maximum value. And what is the maximum value here? B naught. So basically at half power what will happen is that B naught sine cube theta would be equals to, what is the maximum value? That is B naught only divided by 2. Basically this term sine cube theta will be equals to 1 by 2. So directly looking at the problem, directly looking at the question, will you be able to write down this term? Then sine cube theta will be equals to 1 by 2. How will you write down? Okay, what they are asking, half power beam width, and what is given? Radiation intensity is given, that is associated with power only. That means I need to find the point where there is half power. So what is the point where there is half power? So what is the limit of theta? You know that limit of theta is from 0 to pi. So from here, what is the value of theta you are getting? Sine inverse, or you can write down sine theta equals to 1 by 2 to the power 1 by 3. So what is the graph of sine theta? This is the graph of sine theta from 0 to pi. Okay. So 1 by 2 to the power 1 by 2 to the power 1 by 3. That you will be getting twice. Once here, another one here. Right. So if I find the value of theta, what I am getting? Reciprocal of 2, then to the power 1 by 3. So ये क्या हो गया? Oh, sine inverse, I forgot to take sine inverse. 52.53 degree. And what will be the another one? This is 52.53 degree. What will be the another one? Another one will be 180 minus 52.53. Say yes or no? Are you getting this point? Whatever that is happening from here, the same thing is happening from this side. So 180 minus 52.53. So minus 180, 127.46 degree. Now what I need to find? Half power beam width. What that would be? Minus 52.53. So that would be 74.93 degree. So if radiation intensity is given, can I find the half power beam width? Certainly I can find out. And if they were asking me first null beam width, then where they will be null? If they were asking me the location of nulls, they did not ask location of null, but if I had to calculate the location of nulls, so what I need to do? At nulls, U theta comma phi will be equals to 0. That means B naught sine cube theta will be equals to 0. So theta value will be 0 degree and 180 degree. So what will be first null beam width? That would be 180 degree only. That's it. Okay. Now what they are asking? They are asking the overall maximum gain of antenna. gain, they have directly written gain. That means they are asking power gain. Power gain they are asking, and yeah, what they have said is that a lossless resonant half wave dipole antenna with input impedance of 73 ohm. So now they have mentioned the input impedance in the question itself. The input impedance is mentioned. So now you don't need to tell that sir input impedance will be 73 plus 42.5. No, this is wrong. Why this is wrong? Because they have mentioned no. Now they have said that you need to take input impedance as 73 ohm only. So input impedance is 73 ohm and transmission line is 50 ohm. That is lossless transmission line, which is 50 ohm is having its characteristic impedance. Assuming the pattern is given like this, you need to find the overall maximum gain of antenna. Overall maximum power gain. In the examination, it will be power gain only, because gain could be directive gain as well. So they are asking power gain only. If they are asking directive gain, then they will write directive gain. What they are asking? Power gain. So what is the power gain? What they are asking? Power gain. Power gain is neta into directive gain. But they are asking the maximum value of power gain, no? Maximum value of power gain. So maximum power gain. Always when you solve the problems of antenna, just write down what you need to find and whatever that is given. That's it. And you will be able to solve the problem 100%. So you need to take maximum value of this one. Maximum of neta into directive gain. Now neta will be a fixed quantity. So what I need to do? Maximum of directive gain. What I need to take? I need to take the maximum of directive gain. Now what is the maximum of directive gain? That is directivity. That's it. This is what I need to calculate. And what is directivity? Directivity is U max divided by P radiated into 4 pi. And what is U? U theta comma phi. What is U theta comma phi? That is B naught sine cube theta. B naught sine cube theta. They did not mention the range of theta and phi, so by default we need to take the range. Theta by default range is 0 to pi and phi by default range is 0 to 2 pi. Okay. So U theta comma phi is given. So what is your U max here? U max is equals to B naught. U max is B naught. What I need to find? I need to find P radiated. So for that what I need to do? So U theta comma phi, that is B naught sine cube theta d theta d phi. Limit of theta, sorry, sine cube theta, and then U theta comma phi, that is B naught sine cube theta, then sine theta d theta d phi. That will be there. Limit of theta is from 0 to pi, limit of phi is there from 0 to 2 pi. So what we are getting? B naught into, this is your 2 pi. If you take the limit of phi, that would be 2 pi. Now I need to solve sine to the power 4 theta. So how will I solve it? And the limit is from 0 to pi. So I know that I remember the formula for 0 to pi by 2. So what I need to do? Multiply by 2. Then for 0 to pi by 2, what is the formula? For 0 to pi by 2, the formula is, the power is 4. So 4 minus 1 into 4 minus 3 divided by 4 into 4 minus 2, 2, and then 0 I don't need to write. Then into, since it is an even number, so pi by 2. Why it is an even number? You are understanding, no? This is sine to the power 3 theta and this is sine to the power 1 theta. So it is becoming sine to the power 4 theta. Now using mathematics, it will be very tough to solve. So I have given you a formula that I explained in the first lecture of antenna. So again, I am not going to explain here. So you can go there and you can check out if you don't know that particular formula. So this is the P radiated we are getting. We don't have another page. Okay, so what P radiated we are getting here? So this is 3 only. So here 2 and 2 is getting cancelled. This 2 and this 2 is getting cancelled. This 2 and this 2 is getting cancelled. 3 pi square B naught. This is pi, this is 3. 3 pi square B naught divided by 4. This is 2, this is 2, this is 2. Pi pi square 3 pi square B naught divided by 4. Yeah, this is your P radiated. Okay, yeah. So what we are finding, P radiated we are already having. What I need to find? I need to find the directivity. So directivity is, where is the formula of directivity? Umax. So Umax is B naught into 4 pi divided by P radiated. P radiated is 3 pi square B naught by 4. 3 pi square B naught by 4. So that 4 can go upward. So here this and this is getting cancelled. So what you are getting, B naught and B naught is also getting cancelled. 16 by 3 pi. But this is not the answer. I don't need to find the directivity. What I need to find? I need to find the maximum value of this power. Maximum value of this power gain. So what is that? Neta into directivity. So what is your neta here? Your Zin is 73. Your ZL is neta value I need to find. What I am finding here, I am finding the reflection coefficient. The reflection coefficient is 73 minus 50 upon 73 plus 50. So that would be 23 divided by 73 plus 50. So 0.817. So what will be the neta? Neta will be 1 minus gamma square. This will be your neta. So square minus 1 plus minus. So that would be 0.965. 0.965. So now what will be the power gain maximum? So that would be 0.965 into 16 divided by 3 pi. So we are just going by the process, nothing else. Like people will feel like that, sir, there are a lot of formula. First thing, half power beam width, very easy. Then what I need to find, that I wrote down. Then I wrote down what they are asking, maximum power gain. So that would be equals to neta into directivity. So now my task is to find directivity. So that formula I wrote down. Then I find out the value of P radiated, because here I need the value of P radiated. I have the value of Umax as well. So from there I found out the directivity. Now if I have the directivity, I need to find out neta value. So what will be the neta value? That I already know. First I will find the reflection coefficient and then I will find the value of neta. So this is the answer we are getting, into 16 divided by 3 divided by pi. Bas calculation error now je bhai. Okay, 1.63 we are getting, 1.63, but we need to calculate it in dB. So 2.14. Arey wah, 2.142. So this is the value that is there in decimal, but we need to convert it into dB. So tan log tan 1.63, that is 2.143, 2.143 dB. So this is also your answer. Okay, there you go. Very easy process. Just follow the process and you will be able to tell the answer, that's for sure. Now next question. A certain antenna with efficiency of 95% has maximum radiation intensity, that is also given. Maximum radiation intensity is given. Okay. Calculate the directivity when input power is this much, when radiated power is this much. Okay. So let's solve the part A. In part A, what is given? Input power is given. P in is given. That is 0.4. And what else is given? Neta is given. 95%. 95%, or you can say 0.95% is equals to, that means 95% of the power will be transmitted, or you can say 0.95. 95% is equals to 0.95. And Umax value is given. Maximum radiation intensity, Umax value is given, that is 0.5 watt per steradian. And input power is also given. What you need to find? You need to find directivity. What I need to find is that I need to find directivity. So what is the formula of directivity? That certainly I know. Formula of directivity is 4 pi into Umax divided by P radiated, or you can write down Umax divided by P radiated into 4 pi. So 4 pi is there, Umax is also there, Umax is also there, but I don't have P radiated. Do you have P radiated? Yes. Power radiated will be equals to efficiency into the input power. Say yes or no? Right? Power radiated, what that would be equals to? This is the input power and how much power your antenna will radiate? P radiated. So the power antenna will radiate is neta into P in. This we have already seen. Neta value we don't need to calculate. This time it is given, that is 0.95. So P radiated is 0.95 into 0.4. 0.95 into 0.4 into what is the value of Umax? 0.5. So divided by P radiated, that is 0.95 into 0.4. Okay, so what we are getting? 4 into pi into 0.5 divided by 0.95 divided by 0.4. Do we need to calculate it in? No. They are asking in decimal only. So answer is, this is the answer. Okay. In the second question B, what all things are given? Power radiated is directly given. P radiated is directly given. That is 0.3 watt. So will there be any use of efficiency? No. Because P radiated is directly given. 0.3 watt. That is given. And Umax is also given, that is 0.5. Umax is also, although there is efficiency is also given, that is 0.95, and Umax is also given, that is 0.5. But there is no use of this eta, no use of eta here. So let's not cross this, cross it. Now what I need to find? Directivity, that is Umax divided by P radiated, which is already given, into 4 pi. So that's the best thing about these kind of problems on antenna. Like if you don't understand the concept, if you blindly think, then most of the people, what they will do, they will multiply 0.3 into 0.95. They don't even know the concept. So always write down whatever that you need to find and what all information are given. Certainly you will be able to solve the problem. Just this particular topic become complex because people don't even try to understand the concept, they just try to mug up the formula. So that we are not doing here. Divided by 0.3. So what we are getting? 5 by 3 into 4 into pi. So 20.94. 20.94. 94 watt. So not watt, sorry. 20.94. That is the directivity. Is that okay for you? So you try getting this thing. You will not be able to solve it, I guess. But if you can try, you find the directivity of a Hertzian dipole and Hertzian monopole antenna, and then you find the directivity of a half wave dipole and quarter wave monopole antenna. Try doing it. And here one more thing should be mentioned, that this has length L, this has the length DL, and this has the length DL by 2. Okay, this should be mentioned in the question. If this has the length DL, this I am saying that this is having a length of DL and this is having a length of DL by 2. So you need to do this calculation, find the directive gain and directivity of Hertzian dipole and monopole antenna. Hertzian dipole is having DL length and DL by 2, monopole antenna is having the length, and then half wave dipole and quarter wave monopole antenna. Okay. I will take a break, then I will show you the solution. You try doing it. Yeah, so let's start now. What we need to find? We need to find directive gain and directivity for Hertzian dipole and monopole antenna and half wave dipole and quarter wave. So first let's start with Hertzian dipole. So I am starting with Hertzian dipole. Okay, so what we need to find? We need to find directive gain. So first we will find directive gain. From there, directivity is a very easy thing. So theta comma phi. What that would be? U theta comma phi divided by U average. And what is U average? P radiated upon 4 pi. Okay, so we need to find U theta comma phi as well. We need to find P radiated as well. Although we know P radiated for Hertzian dipole, but let's just derive it. I am not gonna write down anything that I already know. I will just derive everything. So first let's find out U theta comma phi, because that is also something that I don't have. What is U theta comma phi? R square into P average. Now can you write down P average for Hertzian dipole? Yes, I can write down. What will be my P average? P average will be E theta S mod whole square divided by 2 eta. That will be my P average. So 1 by 2 eta. Do I know my E theta S whole square? Yes, I know. What is that? E theta S whole square. What is that? That is IDL sin theta upon 4 pi r into j beta. But I need the magnitude. So into beta whole square. Right? What is your E theta S? IDL sin theta upon 4 pi r into j beta into e to the power minus j beta are AR cap. But those are the phase and the direction. So phase and the direction I am not going to take, neither I am going to take the j, because what do I need? I need the magnitude. So this is what we are getting. So let's keep it as it is. So this is my P average, and from here one thing I can do, that is ideal sin theta into beta whole square. Well, let's write down in a better manner. So I am gonna write beta ideal whole square. Yes. Beta ideal whole square sin square theta upon 2 neta into 4 pi whole square upon r square. Why I am writing in this manner? Because I have the P average. Now I can find out u theta comma phi very easily. U theta comma phi is r square into P average. So this r square and r square will get cancelled. So what I will get? Beta ideal whole square, beta ideal upon 4 pi whole square into sin square theta upon 2 neta. R square beta ideal upon 4 pi 2 neta sin square theta. Okay, so this is your u theta comma phi. Now what do I need to find? This is u theta comma phi. I found 4 pi I am already having, and now I need to find P radiated. So what is my P radiated? So P radiated I already know, although that P radiated is 80 pi square into dl by lambda whole square into I naught square by 2. But let's not just apply that formula, and here also I will not come, I naught will come. That is an error from my side. Here I naught will come. Okay, yeah. So what that would be? U theta comma phi beta I naught dl upon 4 pi square into 1 by 2 neta into sin square theta u theta comma phi into sin theta d phi. Limit of theta is going from 0 to pi, and limit of phi is going from 0 to 2 pi. Are you getting this point? So what will be your P radiated? So this part will come outward. That is 1 by 2 neta beta I naught dl upon 4 pi whole square, and then sin cube theta d theta. What will be the integration for 0 to pi limit? That would be 4 by 3. And what about this one? For 0 to 2 pi, that would be 2 pi, right? Okay, so this is your P radiated. So we have found out P radiated as well. We have find out u theta comma phi as well. What do I need to find? Directive gain. So that is 4 pi into u theta comma phi beta I naught dl upon 4 pi square into sin square theta upon 2 neta divided by 1 by 2 neta beta I naught dl upon 4 pi whole square into 4 by 3 into 2 pi. Okay, so this is getting cancelled, this is getting cancelled, this is getting cancelled, and this is also getting cancelled, and this is getting cancelled by 2. So what we are getting? So this goes upward. So 1.5 sin square theta. So this is your GD theta comma phi. So GD theta comma phi is 1.5 sin square theta. Okay, and if I need to find the directivity, what does that mean? Directivity will be max of this GD theta comma phi. So that would be 1.5. So the statement is directivity of urgent dipole antenna. Directivity of urgent dipole antenna will be what? 1.5. So this you need to keep in mind. This you might not be able to remember 1.5 sin square theta, but this you need to keep in mind 1.5 it is. Okay, so if directly in ECE or in ISRO or in BARC, these kind of question can come, that what is the directivity of urgent dipole antenna. So what you will write down? 1.5. Directly you need to remember. So it is 1.5. Okay, we have derived it as well. Now we need to derive it for this. We derived for length dl. Now Hertzian monopole of dl by 2. Hertzian monopole of dl by 2 is equivalent to Hertzian dipole of dl, right? Because whenever monopole is given, what do? We double the length. So it is equivalent to Hertzian dipole of dl, but p radiated of mono dl by 2 will be half of p radiated dipole dl, right? P radiated will be half, power radiated will be half, rest all will be same, P average will be same. Why is that so? Because E theta will be same, H phi will be same, so P average will be same. So if I need to find out directive gain for Hertzian monopole of dl by 2, Hertzian monopole of dl by 2, if I need to find the directive gain, then what that would be? Sir, that would be 4 pi into u theta comma phi divided by p radiated. And what can be u theta comma phi? 4 pi into r square into p average divided by p radiated. P radiated for mono, right? P radiated for mono. Now can I write down in this manner? Here also P average for mono. Say yes or no? P average is also there for mono only. But you know one thing, that 4 pi r square, P average of mono and dipole both are same, but P radiated of mono is half of dipole. So by 2 will be there, so that 2 can go upward. Say yes or no? P here half will be there, no? P radiated of monopole is half. Rest all things are same. E theta is same, H phi is same, P average is same. R radiated and P radiated are half. This discussion we have done a lot of time in the previous video. So I have spent enough time there, you can watch out. Okay. So do you know the value of this much? Yeah. It is 1.5 sin square theta. So what will be your GD theta comma phi for monopole dl by 2? That would be 3, or you can say 1.5 sin square theta into 2, because this 2 will go upward. So what that would be? 3 sin square theta. So directivity, and if you find out the directivity, then you need to take the maximum value. Directivity monopole dl by 2, that would be, directivity would be 3. Okay. So if this question is coming that directivity of Hertzian dipole will be what? 3, and directivity of Hertzian monopole, Hertzian dipole is 1.5, really sorry. Directivity of Hertzian dipole is 1.5 and Hertzian monopole is 3. Say yes or no? Do you agree to this point? Yes. So these kind of questions can also be asked. It is very rare that in gate examination they will ask it, but in ECE or in some other examination they can ask you. And in the gate examination as well, there is no surprise that they can ask the directivity of a monopole. Okay, they can think of framing a question on directivity of monopole antenna. Is that okay for you? Okay, yeah. Now try the second one, but if you try the second one, you will realize that the integration will be very tough. Here the integrating part will be very tough. That integration is not practically possible. Like it is possible, but I don't know how to do that integration. I myself don't know. So integrating part will be difficult. So here we need to remember the certain result. But let's do whatever that we can. So now let's try for half wave dipole. Half wave dipole. half wave dipole. What we need to find? We need to find directive gain, which could be a function of theta comma phi. What that would be? That would be 4 pi into, or let's write down 4 pi theta comma phi divided by p radiated, right? And what is your u theta comma phi? That is r square into p average divided by p radiated. So 4 pi r square, everything is there, but I need to find the value of p averages and p radiated. Okay, page addition. 1 2 3. So p average will be what? 1 by 2 eta e theta s whole square. That would be 1 by 2 eta. Then what will come here? I naught d, sorry. What is the value of e theta? I naught, j I naught 2 pi r, but j I am dropping. J I naught 2 pi r into f theta. Right? Then e to the power minus j beta r a r cap, that will also be dropped. And then whole square of this. Right? So what is your f theta there? So 1 by 2 neta. Then I naught square upon I naught upon 2 pi, you can do I naught upon 2 pi whole square, and then 1 by r square will also be there, which will be getting cancelled because we will find out r square into p average, so that will be getting cancelled. Then f theta. So f theta, do you remember? F theta for lambda by 2. F theta for lambda by 2. So I told you this again and again, we will be using it. So even if you don't remember, you can derive it, but if you remember, you can directly write down cos pi by 2 cos theta divided by sin theta, and there cos pi by 2 will be 0, so that term will not come. There you go. Right? Now can you find out u theta comma phi here? Certainly. That is very easy. R square into p average. So same expression will come. Just the fact that I naught upon 2 pi whole square into 1 by 2 eta into cos square pi by 2 cos theta divided by sin square theta. Well and good. Now what we need to write down? P radiated. So what is P radiated? P radiated, this should be kept in a box. So what is P radiated? What will be P radiated? This thing I need to pick up. I naught square by 2 pi square into 1 by 2 neta, then cos square pi by 2 cos theta divided by sin square theta into sin theta d theta d phi, and then you need to take the range as well, theta from 0 to pi and phi from 0 to 2 pi. Now you need to integrate this with respect to theta, which is difficult, right? This is a difficult task, but let's see what all things we get. So P radiated is also there. What I need to find now? Directive gain. So that is equals to 4 pi into u theta comma phi divided by P radiated. So let's write it down in the next page. Theta comma phi. Look, it is not tough at all, right? Now what will happen? 4 pi will be there as it is. 4 pi will be there as it is. Now u theta comma phi will have this much thing, right? And P radiated will also have this thing, which is a constant that will be coming out. So this and this will be getting cancelled. So what we are left with? Cos square pi by 2 cos theta divided by sin square theta. So on upper side, this is what I am left with, and downward I need to integrate. Downward I need to integrate, which is not that straightforward. So here what I am left with, we need to integrate theta going from 0 to pi and phi going from 0 to 2 pi. So this and this will be getting cancelled actually. So what I will be left with? Cos square pi by 2 cos theta divided by sin theta d phi. Now this I need to integrate. So when I integrate this and put the values, so what do I get? 1.64 cos square pi by 2 cos theta divided by sin square theta. So that is the directivity you get. It might not be that easy to remember this one, but how you can remember this one is that 1.64 f square theta. In that manner you can remember, but it is not that easy. This was easy. Here 1.5 into, here it was 1.5 into sin square theta. 1.5 into sin square theta. This was very easy. Because what I feel is that in the examination they can ask you the directive gain at a particular angle as well. What mostly people remember, this thing they can remember, the directivity of a Hertzian dipole antenna 1.5. But in the examination what they can ask, tell that directive gain at theta equals to 45 degree. Because directivity you need to take the maximum value, and everyone remember maximum value of sin theta is 1, but they don't remember this expression. And if I ask you the directive gain at a particular angle like theta equals to 30 degree, then you need to apply this formula. And here as well they can do the same thing. Here what will be the maximum value of this one? 1. If you remember our pattern, so at 90 degree we are getting it 1. So if you put cos 90 is 0, cos 0 is 1, sin 90 is 1. So maximum value is 1. So here also what they remember is that directivity, another page is there, no? Okay, yeah. So what they do remember is that directivity of a half wave dipole is equals to 1.64, and this is easy to remember, that 1.5, 1.64, and you already know that directivity of a half wave dipole antenna will be more than directivity of a Hertzian dipole antenna, right? So this was 1.5, but this also you need to try to remember, this also you try to remember, and simple formula is 1.64 f square theta, because this was your f theta. So f square theta you can do, otherwise like it will be very tough to derive this thing in the examination. Although steps are not that difficult, you can derive it as well, but yeah, try to remember. If you are not able to remember, then also it is fine. It is not that important. I don't think they will be asking directive gain, and if they ask, they can ask. It depends on them. All clear? Okay. So directivity also we have written, directive gain we have written, all good. Yeah, now what we need to find? Directivity of, or directive gain of a quarter wave monopole. So quarter wave monopole is equivalent to half wave dipole, but power radiated of mono lambda by 4 is half of power radiated of dipole lambda by 4. Power is half, dipole lambda by 2, sorry. So length will be doubled, E theta, P average, everything will be same, but power will be half. So what do you think, what will be the directive gain of mono lambda by 4? That would be mono lambda by 4, that would be twice of this. So 1.64 into 2, 2 into 1.64, then here what will come? F square theta only will come, that is cos square pi by 2 cos theta divided by sin square theta. And if I need to find the directivity, then that would be 3.28. So let's write down in a better manner. Directivity of monopole lambda by 4, that would be 3.28. There you go. Okay, easy it is, not difficult. So you just got to know one thing. What is that? That directivity of mono L by 2 will be twice of directivity of dipole L. Say yes or no. This also you have understood. Why is that so? Because L by 2 is same as L, just power radiated is half, and directivity and power radiated are inversely proportional. So if power radiated is half, that means directivity is doubled. Say yes or no. Well and good. Okay then. Yeah. Now try this question. For an antenna, E field expression is given. find the directivity. This you should be able to solve. You should be able to solve this one. What I need to find directivity. So what is my directivity? My directivity is U max divided by P radiated into 4 pi. You are neither having P radiated, you are neither having U max. So first you need to find U theta comma phi, then you can find U max. So U theta comma phi. What is U theta comma phi? That is R square into P average. Can you find out P average? Yes. R square into E theta s whole square divided by 2 eta. So R square into divided by 2 eta E theta s square. So I only need to take the magnitude. So this and this term will be gone. I only need to take the magnitude. So 25 sine square 2 theta divided by R square. So what you are getting? 25 by 240 pi into sine square 2 theta. Okay, 25 by 240 pi sine square 2 theta. So that is your U theta comma phi. And if I need to calculate the U max, what that would be? This maximum value will be 1. So 25 divided by 240 pi. This is your U max. Okay, U max we have got. Now I need to find P radiated. So for P radiated, so that would be U theta comma phi, that is 25 divided by 240 pi. Now I need to solve this equation as well, because what we need to do, integrate. We need to integration now. We need to do the integration. So 4 sine square theta cos square theta. How did I get it? Because sine 2 theta is equals to 2 sine theta cos theta. So what will be sine square 2 theta? 4 sine square theta cos square theta into sine theta d phi. So what is the limit of theta? From 0 to pi. And what is the limit of phi? From 0 to 2 pi. So what you are getting here? This is coming as it is outward. Into 4 is also coming outward. Now this integration you need to do. So sine square theta d theta. Sine square theta. Okay. So what about the integration with phi? Integration with respect to d phi. So there is no function of phi. So integration with respect to d phi will give you 2 pi. Now what about this one? For 0 to pi, now the function is sine cube theta cos square theta d theta, right? Sine cube theta cos square theta d theta. So now let's solve this one. So what that would be? Double. First double. Why is that so? Because sine cube theta will be positive, which between 0 to pi, and then cos square theta will also be positive between 0 to pi. So whatever that is happening between 0 to pi by 2, the same is happening with pi by 2 to pi as well, right? So this will be doubled. Well and good. Okay, this is doubled. Now I know the answer for 0 to pi by 2. What is that answer? That 3 minus 1 into 3 minus 3 I cannot do, into 2 minus 1 divided by 3 plus 2 is 5, 5 minus 2 is 3, 3 minus 2 is 1, into what? 1 over pi by 2. Since it is even, 3 plus 2 is odd, so it will be 1. So what is the answer you are getting? The integration of this one, 2 I have taken outward. Yeah, everything is fine. So 2 into 2 divided by 15. So that is 4 by 15. So here integration answer we are getting 4 by 15. So 25 divided by 240 pi into 4 divided by 15 into 2 pi. This we are getting as P radiated. Okay, this is equals to what? So this is your P radiated. Now P radiated you have got. U max is also there. Now you need to find directivity. So what will be directivity? U max into 4 pi. 4 pi into U max. U max is 25 divided by 240 pi. Upon P radiated, that is 25 divided by 240 pi into 2 pi into 16 by 15. Okay, so this is getting cancelled and this is 2. So what we are getting? This goes upward, 30 by 16. अरे भाई कैलकुलेशन एरर, यही कमी रह गई थी अब. Now we need to check it wholly, completely. There is some calculation error somewhere, I need to check it now. Yeah, so the error is in our answer. Okay, so here 3.75 by 2 will come. So that is the error. Our calculation is fine and everything is fine. So answer will be 30 by 16 only, and that would be 1.875. So yeah, this is the exact answer. Actually the error was there in the written answer, not in the process. So process also, you know, every single thing you can solve, right? Let's go to the next one. Let's go to the next question. So this was asked in GATE examination, so you can solve it very easily. A half wave dipole is kept in xy plane and oriented 45 degree from x-axis. So xy plane, it is lying in xy plane. Okay, it is lying in xy plane, and oriented along 45 degree from x-axis. 45 degree from x-axis. 45 degree from x-axis. So this is your antenna, 45 degree from x-axis. Determine the direction of nulls of radiation pattern. Phi value is from 0 to pi, and the theta angle is from 0 to pi as well, is measured from z axis, and the angle phi 0 to 2 pi. Phi is from 0 to 2 pi is measured from x axis in the xy plane. Okay, phi is measured from x axis and theta is measured from z axis. This is what they are saying. So where is the z axis? X cross y towards me. So here is your z axis. So where is the antenna lying? Antenna lying making 90 degree from z axis, right? And what do you need to find? You need to find the location of nulls and the location of maximum radiation. Location of nulls and maximum radiation. So if this was our antenna, so how we were getting our wave pattern? Like this and like this. So here there were nulls, right? It was any kind of length. It was length, it was same for lambda length as well, it was same for lambda by 2 length as well, and it was same for Hertzian as well, right? And when the length became 3 lambda by 2, at that time what was the standing wave pattern? Okay, let's not erase it, let's keep it as it is. And when the length became 3 lambda by 2, the pattern was something like this, that here it was having some, then here it was having some, and then like this. Okay, and the similar scenario was here as well, like this. So you noticed one thing. Which thing you noticed? That always in the direction of the antenna there was nulls. Wherever the antenna is kept, here the antenna is kept, so it will have radiation pattern like this, but along the axis of antenna, always there will be nulls, right? Along the axis of antenna there will be always nulls. This was for 3 lambda by 2. So along the axis of antenna, no matter whatever the length is, always there will be nulls. And here which length is given? Half wave length for lambda by 2. So for lambda by 2, do you remember what kind of standing wave pattern you get? At the 90 degree angle, what I mean to say is that from here at the 90 degree angle, you get these 2 lobes. So from here at 90 degree angle, I will get 2 lobes. At 90 degree angle, I will have my maxima. So basically this kind of pattern I will get. At 90 degree angle, I will have my 2 lobes. Right, and this will be the location of nulls. This will be the location of nulls, and this will be the location of maximum radiation. Maximum radiation. And all these are happening. Where it is happening? All these are happening on xy plane. All these are happening on xy plane. Because in xy plane you get the biggest circle. If you remember, on xy plane you get the biggest circle. So that's why we will make the pattern of xy plane. So all these are happening on xy plane. This pattern we made for, this was our E plane pattern. This was our E plane pattern. And what is this? This is our H plane pattern. Now if you keep on going in the direction of Z, that means theta value is getting decreased. And if the theta value is getting decreased, that means the radius of circle will keep on getting decreased. So maximum radiation will be here on this particular surface only, or you can say the maximum radiation will be there on this particular plane only. what I mean to say is that people will be having that doubt, sir, that sir, these two lobes will be there on for theta equals to, not only for theta equals to 90 degree, these two lobes will be there for theta equals to 45 degree as well, for theta equals to 30 degree as well, for theta equals to 20 degree as well. So how you can say the maximum radiation is on this plane only? Because on this plane you will have the maximum H plane circle, because in H plane you will have a circle only. But if you keep on going towards theta, if your theta is getting decreased, that means from 90 degree to 80 degree to 70 degree, then if theta is getting decreased, then the size of circle, or you can say radius of circle, will be getting decreased. And if the radius of circle is getting decreased, that means the total radiation will be lesser. So on this plane you will get the maximum radiation. So if they are asking the position of nulls, then no doubt you can say position of nulls is at 45 degree, and so position of nulls, position of nulls, position of nulls will be at theta equals to 90 degree. In theta equals to 90 degree, here what will be the position of nulls? Making an angle of phi equals to 45 degree. Also, what could be the other answer? This is also a position of null, no? So this is 45 degree, and this is 180 plus 45 degree. So theta equals to 90 degree, and phi is 45 plus 180 degree. What that would be? 225 degree. Say yes or no? Okay. Now here in this option, if theta equals to 45 degree and phi equals to 45 degree was written, theta equals to 45 degree and phi equals to 45 degree was written, would that answer be correct? Yes, that answer will also be correct. Because if you remember the 3D diagram, do you remember the 3D diagram? Should I add the diagram here? I need to add the diagram because I need to give a very important conclusion here. So I will add up that 3D diagram, okay? Because I need to give a very important conclusion, because what people think is that all this is happening in XY plane. So that's why theta equals to 90 degrees. So they are eradicating these two options. This is not the reason why these two options are getting cancelled. The reason is here phi value was wrong. Here phi value was 90 degree. Here phi value was 135 degree. So but phi value could be 45 degree and 225 degree. If the option was here 45 degree and here 225 degree, then these two options would have been also correct, and this would have been also correct. And here if it was 225 degree, then all four would have been correct. But a lot of places I have seen that okay, this antenna this antenna is lying in XY plane. So that's why theta will be always equals to 90 degree. Why theta cannot be 45 degree? What I mean to say is that this radiation pattern will not only be in XY plane. This is only the 2D diagram you are seeing. If you remember the 3D diagram, what happens there? This complete kind of circle will be there upward as well. All these things will be there upward as well and downward as well. From theta equals to 0 to 180 degree, you get all the patterns. Just the thing is, what you are getting a apple-like shape, right? You are getting an apple-like you are getting a apple-like shape. And there we were saying that in that along the direction of my antenna, where is my axis? Along the direction of my antenna, along the axis of my antenna, there is no radiation. So always there will be no radiation. Along this direction, always there will be no radiation. Whether your theta is 45 degree or your theta is 35 degree or your theta is anything. So for theta equals to anything, theta ranging from 0 to 180 degree along the direction of your axis of antenna. What I mean to say is that position of nulls, if I write down position of nulls, so this will be the true answer, because now MSQ has been also introduced. So position of nulls will be theta equals to theta belonging to anything from 0 to 180 degree, and phi should be 45 degree or 225 degree. There you go. Okay, but they are saying that you need to take the range of phi from 0 to pi only. If I need to take the range from 0 to pi only, so let's remove this line. Let's make this question better. Because this was asked in GATE examination previously. There was no MSQ. So let's make this question better now. Okay, yeah, so now it is better. That determine the direction of null in the radiation pattern in the radiation pattern. Here the angle is from there. So theta value, phi value can also vary from 0 to pi now, 0 to 2 pi now, and theta can also vary from 0 to pi. So all the limit, all the complete 3D diagram, complete radiation pattern we are taking. Are you getting this point? So these are the position of nulls. Let's keep them in boxes only. Let's remove it off and let's not make this better. Now I need to find the position of maximum radiation. Position of maximum radiation. So what is the position of maximum radiation? At theta equals to 90 degree, but making an angle of 90 plus 45. So maximum radiation at theta equals to 90 degree, but phi should be making an angle of 135 degree, right? Because 90 plus 45, because at the 90 degree, like at the perpendicular, you get the maximum radiation. So 90 plus 45, that is 135, and then again adding 180 more. So 135 degree plus 180 degree, that would be 215. 315 degree. Okay, so this is the answer for maximum radiation. Now again think, now people will be having the doubts that sir, why you did not write 0 to 180 degree here? Why I did not write 0 to 180 degree here? Why I did not take the range 0 to 180 degree? Why I am taking the range theta equals to 90 degree? In the initial only I explained this, that whenever you get theta value from at 90 degree, you are getting this maximum circle. But if you went to 80 degree or 70 degree or 60 degree or 40 degree, then the circle radius will be getting smaller. So this radiation pattern will also be getting smaller. So if you remember that exact diagram, what was the diagram? If you remember the 3D diagram, if you remember the 3D diagram, then you would see that it was something like this. That means here you are having the maximum radiation. At 90 degree, you are having the maximum radiation. Then your size of circles were getting smaller. Your size of circles were in this kind of structure. In this kind of structure, there was the radiation pattern. Apple type structure was there, and in between there was nothing. And your antenna was placed somewhere like this. So along the axis of antenna, there was no radiation. Okay. And here perpendicular, there was the maximum radiation. But just as you were going up, that means your theta was getting changed. So at theta equals to 45 degree, your radiation were getting lesser. Theta equals to 45 degree. So at theta equals to 90 degree, you will get the maximum value to be 1. But at theta equals to 45 degree, you will get the maximum value to be 1 by under root 2 only. What I am plotting? This I am plotting as normalized value of E. Right? This kind of pattern you are getting. You go to the previous lecture and see the 3D pattern. That how I showed you the 3D pattern. So all these things are clear, then this would become a very good question. Like if this was a MSQ, then I would have framed it very nicely. What I would have done, I would have put theta equals to 45 degree as well, 45 degree as well, and phi values I would have put 225 degree and 45 degree. Then people would be thinking, okay, the radiation pattern we are getting in XY plane, so theta should be equal to 90 degree only. No. Nulls are nulls only, no. Whether you take theta equals to 45 degree, whether you take theta equals to 30 degree, nulls will be nulls. Nulls means 0. Here your normalized value of E is 0. Here your normalized value of E is 0. So nulls will be nulls only. 0 will be 0. Whether you take theta equals to 45, you take 90, you take minus 40, you take 45 degree. Here it is not 45. Here it is 135. Really sorry. Here it is 135. And then it will be theta equals to 180 degree. And this was your theta equals to 0 degree. So whatever you take, nulls will be nulls. Nulls means 0 amplitude. So that's why here theta was ranging from 0 to 180 degree. But here what I am asking, find the direction of maximum radiation. So what I can say is that for theta equals to 90 degree, this is my maximum radiation. For theta equals to 45 degree, this is my maximum radiation, but this maximum radiation is lesser than this radiation. The maximum radiation for theta equals to 45 degree is lesser than maximum radiation of theta equals to 90 degree. So overall total maximum radiation you are getting at theta equals to 90 degree only. So very, very important point. I could have made this question very nicely. Are you getting this point? I could have framed 4 options there, that at theta equals to 90 degree and at phi equals to this much degree, you are getting maximum radiation. At theta equals to 90 degree, at 5 at this you are getting the maximum radiation. Then at theta equals to 45 degree, in that manner I could have framed the option. Okay, so always remember nulls means 0. So along the axis you will always get 0. Along the axis you will always get 0, and perpendicular you will get the maxima. But that is there for lambda by 2 only, for lambda only, for Hertzian only. For lambda by 4 as well, the same thing was there as far as I remember. I don't remember exactly, but for lambda by 4 as well, you are getting the same kind of pattern. For 3 lambda by 2, it was different. For 1.25 lambda, it was different. But for these lambda by 4, lambda and lambda by 2, you are getting this kind of pattern only. So there you know that nulls will be always along the axis of antenna. Nulls will be always along the axis of antenna or along the arms of antenna. Along the arms of antenna, you will always get nulls. And maxima you are getting at theta equals to 90 degree. For lambda by 4, for lambda, and for lambda by 2, and for Hertzian. And now, in the axis of antenna, at 90 degree, in the axis of antenna, at perpendicular, you will get the maximum radiation just as the value of theta decreases. That means if you are going in the direction of, if you are going towards z axis, then what will happen? Then if you are going towards z axis, then radius will be getting smaller. And if radius is getting smaller, that means the maximum radiation will also be getting smaller. What do I mean to say is that at theta equals to 45 degree, the maximum radiation will be lesser. So this is the conclusion of the whole problem. I hope you must have understood a lot of new things in the analysis of this particular question. Okay, let's see the last question now. Last question of this particular lecture. Try solving it. An antenna located on surface of flat earth transmits an average power of 200 kilowatt. This we already know. P radiated is given, that is 2 into 10 to the power 5 watt. Assuming that all the power is radiated uniformly over the surface of hemisphere with the antenna at center, then find the time average pointing vector at r equals to 50 kilometer. So I can write down 5 into 10 to the power 4. So which formula I will apply? Will I apply this formula, that my P average, what did I tell you? P radiated, if it covers the distance of r, so P radiated by 4 pi r square into directive gain. But here what they are assuming, that the power is radiated uniformly. Power is radiated uniformly. What does that mean? It is isotropic. And for isotropic antenna, what this will be? This will be 1. So is this formula correct? P radiated upon 4 pi r square. No. When I was writing down this formula, P radiated upon 4 pi r square, I was again and again saying, assume as sphere, assume as sphere. We are assuming as sphere. But if it is a hemisphere, then the surface area will be half. Let's derive it again. Let's derive this formula again. So what is my GD theta comma phi? That would be r square into P average divided by U average. And how I was getting U average, if you remember, we started with P radiated. Then we told that, sir, here you will have U theta comma phi, then sin theta, d theta, d phi. Now we need to take the limit of theta and limit of phi. Now for a hemisphere, you just let me know one thing. For a hemisphere, this is your hemisphere, right? For a hemisphere, if this is your theta equals to 0 degree, then what this will be? Theta equals to 90 degree only. And what about the range of phi? If I am calling this as phi equals to 0 degree, then it will again complete the circle and it will go to 2 pi. So phi will go from 0 to 2 pi, but theta will go from 0 to pi by 2 only. This was the catch here. Now if I need to find U average, that means I will take this outward, U average, and what that would be? Now I need to integrate. So limit of phi, that would be 2 pi only. But now I need to integrate 0 to 2 pi sin theta d theta. What that would be? It would be 1. So what I am getting? U average into 2 pi. This is my P radiated. So from here U average is P radiated by 2 pi. Are you getting this point? For hemisphere. So it depends on the range as well. Directly, if blindly I would have told this formula, then you would be getting it wrong. So now what will be your P average? So from P average, if I find GD theta comma phi into U average, what is U average? P radiated upon 2 pi r square. And for isotropic antenna, this would be 1. Right? So what we are getting? P average is equals to P radiated upon 2 pi r square. So what is P radiated? 2 into 2 to the power 5 divided by 2 pi into 50 kilometer it was, so 25 into 10 to the power 8. So 40 by pi micro watt per meter square. Did you understand this calculation? 40 by pi micro watt per meter square. How did I do this calculation? So what I am getting, 10 to the power minus 3 divided by 25. This is what I am getting, watt per meter square. I need my answer in micro. So what I need to do? 1000 divided by 25 into 10 to the power minus 6. So what we are getting? Certainly pi is also there. So 40 by pi micro watt per meter square. Okay. This is the answer. Well and good. Fine. Okay then. Thank you very much. I hope you must have understood a lot of terms, a lot of new things. You are enjoying the antenna lecture. The antenna which might seem tough to you, it is becoming easier or it is becoming tougher, because I know the things are not taught in this much depth anywhere, and I'm not being arrogant, but it is what it is. Like teachers certainly know these kind of things, they also know this kind of depth, but sometimes it is not taught. So this is what I am saying. Like a lot of teachers teach EMFT and all these are equally good. Like some of them are not that good, but a lot of teachers are pretty good in EMFT, whoever teach in our online industry. So but I hope now your EMFT, whether you say transmission line, whether you say EM wave, whether you say waveguides, or whether you say antenna, these things must be getting stronger. If it is getting stronger, then do comment down, do let me know that how you are finding out the content, and are you able to visualize all these things now? Are you able to visualize the radiation patterns or not? Okay. Yeah. So I hope this I was able to give you enough visualization, although I did not attach the 3D diagram, but I hope still you understood what I mean to say. That just as we get upper, then circles were getting smaller. At 90 degree we were getting the maximum circle. So if I need to tell the maximum radiation, then theta equals to 90 degree. But if I need to tell the nulls could be anywhere. At 45 degree, at 30 degree, at 0 degree, at 20 degree, at 45 degree, at 50 degree, 70 degree, anywhere. So for nulls, this is the location, and for the maximum radiation, this is the location. Okay, and maximum radiation you always get perpendicular to the axis of antenna, and nulls you always get in the direction of antenna, or you can say along the axis of antenna. Well and good. Okay, now in the next lecture we will continue from here only. What we need to study? We need to study about Friis equation, but before that 2 more terms we will study. What are those 2 terms? Those 2 terms are aperture area, or you can say like aperture area we will study, effective aperture area we will study, and maximum effective aperture area we will study. All these are 3 different terms. Okay, these we will study, and then we will study about polarization loss factor, and after that we will study about our Friis equation. And like once we are done studying about aperture area, after that Friis equation you already know. In Friis equation we are not going to understand anything new. You already know 100% of the things of Friis equation you already know. So when we start the Friis equation, you would be already knowing everything about Friis equation. Like many times this Friis equation becomes pretty complex topic, but since we have breaking down these concepts, then I hope you are finding it pretty good. Okay, so next lecture is also very important, and that also you will love it. Thank you very much. Let's meet in the next lecture.